Good morning. We hope that you attend the talks not just for reimbursement, but actually because you're learning something. So I had a look at the various profiles of people here, and there is a bit of heterogeneity. So I'm going to talk largely about work on trade, and to some extent IO, industrial organization. There are two lenses to do the study, okay, to work in this field. One is basically to know a lot about the trade patterns, what are happening, stylized facts. These are probably things that you really need to do research if you are working on India, for example. But there is another aspect which is tools. What are the tools that are acceptable to do good work in these fields? Okay, so the way I look at it, while I'm going to be talking about some of these topics, I notice that Veeramani is going to talk about trade at the end of, I think, the last day. So the way we are going to do this is I'll talk today largely about a methodological way of thinking about things. Okay, so what I say today is actually would probably feed in nicely to the last lecture, which is on econometrics and things like that. Whereas the final lectures that Veeramani is going to give is probably going to be more about India's trade, okay, which is more about facts, stylized facts, what is interesting, what is happening. So good research mandate requires marrying the two to actually get international quality work. Okay, so having said that, I'm not sure what is the level of kind of relative understanding of econometrics in this room. So what we are going to do is we are going to do a quick refresher, okay, without any of my slides and stuff, and I'll basically ask various people without trying to put you on the spot, but actually try to get a sense of whether you understand what a regression is. Okay, and with that understanding, and hopefully a shared understanding among all of us what it really is, we are going to start talking about various estimation exercises in the context of trade, industry, and so on and so forth. Okay, everyone okay with that? Okay, it's a deviation from the script a little bit. Okay, so how many in this room have actually run a regression? Okay, that's good. How many have studied about regressions? You could run regressions without studying about it also. Okay, that seems actually a slightly different set at some point. So let me ask, here's a so it's a regression on the left hand side, which is wages. Here's schooling years. Here's some variable that characterizes the caste of the person, and and there is something here called epsilon. Okay, so here's a regression. So can someone tell me what is the what are we trying to achieve by running or finding these A, B, and C's? What is, so let's say we do something and then we get some value of A, B, and C. What is the purpose of the exercise? Yes.
The coefficient of B will show the impact of year of schooling on wage.
Okay.
In terms of per day, per hour.
Per day, per hour. Okay.
So it depends on availability of data.
Let's say we have data for all these things. So it will show the impact of years of schooling or whatever education on wages. Is that's partly correct? Yeah. That's the same thing as he said. So another way to say the same thing is that it will tell us how much does one more year of schooling, how much does that change wages, right? So it's the same thing as saying what is the impact of but is that complete? Okay, ceteris paribus. What does ceteris paribus mean here? Huh? Okay. So what is held constant? Okay. So here is only one. So forget about everything. So cast here. So what does that mean? Being held constant. What does that mean? Cast held constant. Someone else.
In the same cast, when the cast is not changing, what is it's like the degree of linear association between the two variables?
Okay.
Between wage and school year, like how much wage is changing for a change in school year,
Mm-hmm.
and the cast is, the cast is not changing. I mean, cast of the people is not changing.
Okay. Partly. Anyone else?
When you control the impact of caste on wage, after that, what is the actual impact of school year of schooling on wage?
Okay. All right. That's better. How does a regression give you that? I mean, what is a regression doing? I mean, let's say we all agree. Yeah, we say this all the time. Ceteris paribus, cast held constant.
Predicting.
Huh?
Using all data to predict something.
Who's predicting what?
So we are trying to predict the wage rate if
Huh.
they have the data of school years and caste.
Oh,
Is that causal?
looking at only B. I just wrote all three of them. Yeah, the back.
So it's the relative contribution of the individual contribution of all the factors which determine the wages in the first place, and if they determine, to what extent they are determining.
Okay.
Any change in any of the variables, what will be the change in the wages that is obtained from that particular equation.
Okay. Let's say that I were to run just that. That's also a prediction. So what's the difference between this prediction and that prediction? What does a prediction mean? There were two words used here, right? She used the word causal effect, you used the word prediction, right? You used the word determination. So what's the difference between all these three things? Or is there a difference? Yeah? You used the word prediction, she used the word causality, causal, you've used the word determination. What is the difference between all these things? Anyone? Yeah.
There is a population and there is a sample.
Yeah.
From the sample, we try to predict the population. The parameters are like, this is a functional relation.
Mm-hmm.
We want to see, like wage is a function, in the second equation, wage is a function of school years,
Mm-hmm.
and we have data for that. And from there, we try to estimate the effect of school years on wages at the population level.
Okay. So let's do the first exercise first. Let's say that I am interested to know what the wage is, and someone has provided me the years of education data and nothing else. Okay. So I do some estimation, I find this B, and so given this is all I know about the world, I plug in the value for each person's years of education, and I get a predicted value for the years for the wages, right? So that's one exercise. Okay. Now let's say that instead of years, someone says that okay, so I find that years of education is doing a great job at predicting. Why don't we just make sure that everyone has, let's say it's positive, okay, that's also not obvious that it should be positive, but let's say it's positive, that this B comes out to be, in this B comes out to be a positive number, okay. And so on the basis of that, I say that, okay, let's give those people who don't have education, let's give them more schooling, okay? Because I just predicted and I saw that it does a good job, and there is a the B is positive. Does that immediately imply that if I give more education to everyone, there will be higher wages? Huh?
One part of the story. We may include more variables to make it more accurate prediction.
What does that mean? Why not? Give me an example, why not? Give me a reason why when I put your education, B is positive, and yet that does not mean that if I give you more education, or those people who have less education, if I give them more education, that their wages will go up. Huh? Yeah, so I give one more unit. So B is positive, so I give one more unit of education. Sabko school bhejo. Yeah? Give me another factor.
If it's a correctly specified model,
Yeah?
epsilon has nothing. If
Okay.
there are no other
If epsilon has nothing, it has no role to play in the whole thing. It's deterministic.
becomes deterministic.
Yeah, no, it has a role to play. I'll come to epsilon later. So the question is, and she's kind of pointed out the right answer, that if I give you one more unit of education, then why is it not necessary that it should have a role to play? Because notice in this room, well, not in this room because all of you are more or less homogeneous, but in a room where there are people with different levels of education, why do they have more education? Why do some people have more education and others have less? Well, it could be that they come from particular caste segments of society or income levels of society, and so richer people just generally are able to study more, okay, and richer people are able to get good jobs, right? So it's not the education that in fact gives you higher wages. It's the fact that you come from maybe a forward caste or an high income household that gives you both a higher education level as well as higher wages, right? Now the thing is that if in this room I do this prediction, it will still do a great job, right? Because it's true that people with higher levels of education will get more money, but it's not because of education. It's because the higher income people, wealthier people, tend to study more, and wealthier people tend to get better jobs for their children, and therefore what I think is that education is causing in some sense the higher wages is completely a false statement. So if I were to come here and give a poor household kilo, I'll send you to school, right? They'll go to school, but they don't have any support system, they don't have parents to help them out get jobs. You may not find any effect on wages for these people at all, okay? Is that point clear? So the statement that if I run this wages on years of education and I observe a positive sign, yeah, this is a true statement. It's true that people with higher levels of education earn more money, right? This is true statement. This is an association, as was pointed out, okay? But to move from an association to making the statement that education causes higher wages requires you in some ways to get rid of all these other stories, right, at the background, that educated people come from richer households, come from forward caste, have a lot of good things happening in their households, mothers are helping them out doing homework. These will not exist in other households which are less educated, right? So causal statements are very important, because once you make a causal statement, you are in fact saying that jiske paas education nahi hai, let's just give them more education and you will observe the same prediction, right? Much higher wages. This statement may not be true, okay? But on the other hand, if I enter this room and I don't know your wages, and I say क्या मुझे guess करना है, so you tell me, I can give you my education, but I won't tell you how much I earn, right? And if I have a model where I know what the B is and the A is, I can kind of do a good job at predicting your wage. Okay? These are two different exercises. One does not care about whether something is causing the other thing. One just says कि मुझे एक चाहिए कि मुझे guess करना है, and there is something about you which does a good job at guessing, right? And so I want to know, if you give me some of these things about you, then I can kind of guess what your wage is, right? So that has no requirement to understand कि ये cause कर रहा है कि नहीं कर रहा है and stuff like that. Okay? If you come from a particular district, maybe you're, it's a district which does well. It's district say, oh, then you must be earning a lot of money. Okay? It doesn't mean that there's something in the district that causes it. Okay? It's just that it's just a typology of you. It's some sort of descriptive about you which does a good job in prediction. Okay? Now, typically, when we work in policy, in stuff, we don't care about just description. Description is interesting to understand and to get a sense, because you cannot do any work without understanding what data is. But typically what we want to do is we want to make interventions, right? We want to do something like increase your education level. So we want to know that if we increase your education level through a policy tool, will your wages go up or not? And for that, we need to know what is the pure impact of increasing education. Okay? So the pure impact is ceteris paribus, is basically holding everything constant, this kind of interpretation, right? That it's just the pure thing which comes from education and nothing else. Okay? Now we have used the word control, ceteris paribus, all that. How does the regression do that? So here the underlying assumption here is higher schools of years of education and higher wages, let's say there's a positive association. It's not really it's not purely because of school years. Maybe because people with a forward caste have higher years of education and then they can get their children jobs, so higher wages. Okay? So you put that in. But if you put it in, how does it do what's the mechanics? How does it ensure that suddenly कि ये pure ही है, right? We always say this in regressions, right? That it controls for things. What does that mean? Control for things. How does it do it?
Partial correlation.
So what's a partial correlation? Controlling for? It's a chicken and egg thing, no? So it's basically we keep saying the same thing. It's circular. But how partial correlation is the covariation of two variables, removing the impact of others. Removing the impact of others. What is removing impact? What does it mean? How does a regression remove some impact? वो तो topic number 10, 12. Yes, this is very important because there is no point in doing very complicated stuff if we don't get these things right. Yeah, okay. I heard some. Are you? Yeah. No?
Are you talking about one specific, talking about OLS or no?
Let's say we talk about Oilless. Just make it simple. Let's say it's an ordinary least square regression method. How does the ordinary least square regression method give you an answer which is the impact of schooling on wages caste held constant?
So all these factors would be if you are not taking caste, but you're just measuring the impact of schooling on wages, probably all of the factors are included in error terms.
No, error terms is a separate business. We'll talk about errors next.
Won't it be included in that? Because if you are measuring only the impact of schooling,
No. So we have moved. Before I talk about the errors, we have moved from here to here. Okay. So the question, the reason people said is, if you run this, then B is the change in wages by change in school years, caste held constant. So I'm asking, this is one thing way to say it, but how do you achieve it in a regression? There must be something. let's say that there are two castes. Okay, if I were to tell you that, give me I don't let you run a regression. Okay, and there are, let's say, 2 schooling years. There are 2 levels, illiterate ho ya nahi ho. Okay, and there are 2 castes. Then can you tell me another procedure which will give me the impact of being literate on wages? Sorry, minimize? No, don't run over. Here's the advanced concepts. I am just giving you. There are 2 castes and there are 2 education levels, literate, illiterate. Okay, I am giving you. So let me write down. Yeah, so let's call it C1. C2, these are 2 castes and there are 2 levels, literate and illiterate. Okay. So the data I have is I have the wages for all. So let's call this W lit 1, W lit 2, W illiterate. So that's I1 and WI2. सब है ना, एंगल है तुम लोगों का, कास्ट भी है इसमें, लिटरेसी लेवल भी है, वेजेस भी है. Forget about regressions. Tell me just common sense. How would you give me the impact of being literate? What would you do? I'm sorry? There is no school year. There is only 2, literate and illiterate. Yeah. There is no regression. I am not allowing any regressions. Yeah. I am not allowing any of those things.
Each observation which is falling.
This is by the way the average, because ऐसा नहीं है कि एक ही आदमी का कास्ट है. So these are all averages. This is the average wage for caste 1 among literate people in caste 1. This is the average wage for illiterate people in caste 1. This is the the average. So they are all averages. ये observation मतलब मैंने, you give me all the observations, I can always give you an average, right? So I have calculated the average wage for literate people in caste C1. Similarly, wages for literate people in caste C2. Same with literate. First, you calculate this difference. One. So let's call it W C1. ये caste 1 का हो गया. Similarly, okay, I'll just tell you the difference in the 2 wage levels for caste 1 among literate and illiterate people. So I'm just going to call it the difference, okay, and I call it delta. For caste 2, the difference between literate and illiterate, let me call it WC2, difference delta. And so for the population, what's the impact of being for being literate? So caste 1 के लिए WL1 है, WC1 है, caste 2 के लिए WC2 है. So then if you average those 2, right, you will find the impact of being literate. How is caste held constant here? इसमें भी तो कहीं ना कहीं caste is held constant. Why? What is the step here where caste is being held constant? Exactly. That when we are talking about the difference between literate and literate, we are calculating it for each caste separately. Okay? So I am not comparing, for example, WL2 to WI1, right? I am basically comparing within the same caste. Okay? This is the notion of what it means to be held constant. Okay? Now, from here, we are claiming we are doing something like this there also, right, in a regression. Right. So, how? By the way, what will you do if you have instead of literate, illiterate, if you have all the years? So, like primary, middle, so on and so forth.
Each year you have separate columns.
You will have to have many calculations, right? You will have to have middle say primary एक difference, primary says alag level difference, and so on and so forth. For the same caste though, right? Similarly C2. What if you have many castes? What will you do?
That will extend simultaneity.
Yeah. So you will have many of those, right? What do you do to variables where it's not like these bins? It's like years of schooling. Years में तो बहुत है ना, 1, 2, 3, 4 से 15, right? You'll have to do it for many on both sides, many castes, many years. Okay. So this way so these are called creating bins, right? You are creating a bin of the caste, मतलब same caste, and then you are trying to look at the different bins of education level, किसमें difference हो, then what will happen to the wages. Okay. So the problem is that think about a variable like income, right? If you were to do that, you go crazy. Every level of income is a possible level of income. So will you do it for every rupee? Will you do it for a difference in every paisa? It's all very arbitrary. You can't. So you cannot go down. So the idea is the same, but you cannot go down very far on that path. Okay. But we want to do something like this kind of analysis when we say we want to run a regression. Okay. This is the intuition behind. We want to run, when we want to say that something held constant, we want to be able to do something like this. Okay. So anyone else now? Given that this is what we want to do. Let me give you a hint. It's a combination of a prediction and something else. Prediction involved in this. Nahin? Okay. Let me now talk about another way of doing this. First exercise is I run a bivariate regression, or basically just one variable, right, of caste and wages. Okay. Very close to your idea. Now for every person in different caste, I can kind of predict a level of wages, right? So if I estimate these things, you give me a caste, I can give you a predicted wage. Okay. This is step 1. Okay. What can I not predict with caste? What part? In this, what is the part that I am not predicting with my caste? What is the part of the wages that is not predicted by caste? In that equation, this part. Right. So I have just used caste for prediction, and I predicted something which is this predicted wage, right? And so wages, basically the actual wages for everyone is just the predicted wage plus that term. Yeah. I put a hat because of predictions. Ram Guha once made a joke about econometrics, that the only thing he remembered, he's an economics student, he remembered from econometrics is some letters wear hats and others don't. So remembering that is very important. Okay. Okay. So there is wages, there is predicted wages from caste, and then what you cannot predict, right? The amount of wages of each person that cannot be predicted by his caste. Okay. All right. So another way to think about it is this part is just the actual wages of people minus the part that you can predict using caste. Equivalent statement. Okay. Step 2. let me take years of schooling, okay, and run a simple similar prediction exercise, right. Now, you have a particular caste, I want to predict what your years of schooling is. Okay. You give me a caste, you give me years of schooling, I can write down a prediction model, right. So, delta 1 hat plus delta 2 hat times caste is the predicted years of schooling, right. These are as predicted by caste. Everyone clear? Right? Clear? So, you give me years of schooling, you give me your caste, I can tell you how much does your caste predict your years of schooling, right. I can run that model, and then just like the one above, you can see that epsilon 2 hat will be, what is the interpretation of epsilon 2 hat? Epsilon 2 is here. Huh? What is the interpretation of epsilon 2 hat? It is the amount of schooling that is not predicted by caste. Okay? So, this is, so years of schooling, your actual years of schooling minus the predicted years. Years of schooling that is not predicted by caste. Okay? These two steps. First, what is the part of wages that is not predicted by your caste? Second step, the amount of years of schooling that is not predicted by your caste. Okay? What should step 3 be? On epsilon 2 hat. Okay? What is epsilon 1 hat? Just to remind you, it is the wages not predicted by caste, right. What is epsilon 2 hat? And there is of course some stochastic part. Okay. This is what? This is what? Epsilon 2 hat is the years of schooling not predicted by caste. Okay. I run regression of this and that. What is the interpretation of B? What is B now? Right. It is the correlation between schooling and wages, but the part of schooling and the part of wages that is not predicted by caste, right. So, does this coefficient that you estimated have any correlation with caste? No, because by construction epsilon 1 hat was the part that is not predicted by caste, epsilon 2 hat is the part that is not predicted by caste. So, of course, when I have a correlation between epsilon 1 hat and epsilon 2 hat, that has no correlation with caste. Okay. Is that point clear? Right. This is exactly what you get. So, if you do this, just try it on your computers. This is exactly what you would get if you ran a regression of A plus B of years of schooling plus C caste plus epsilon. What you get here as B is exactly what you will get as B here. Okay? You just do not see it because the computer is doing it, right. It is exactly, if you do not see it because the matrices, they are all determinant matrices, they are all inside, but this is exactly equivalent way of doing it. But once you do it this way, it kind of should be clear to you what it means by controlling for. So, here I have put caste, but in principle I can put many more variables, right. So, let us say I have caste, income, mother's education, so and so forth, right. What I will do, I will look at the part of wages that is not predicted by caste, mother's education, all these other things, right, you can think of. Similarly, I look at years of schooling that is not predicted by mother's education, caste, income, so and so forth, right. And now if I see a correlation between the two parts that are not associated with all these other things, then this association is because of schooling and not all those other things that are there. Okay. Because the regression does this, we can make the statement that when we run this regression, that this coefficient is the impact of years of education, all these things held constant, but actually in statistical terms it means the effect of all these things removed. Okay. They are exactly equivalent statements. This particular interpretation is called the Frisch-Von theorem in econometrics. So, if you want to look where it is, just open the book Frisch-Von theorem, you will see they have worked out. It is always the kind of proof that when I was a student, I just skipped over it. You have one more theorem to look at, right. But in fact, it gives you the best way to think about what a regression means. Okay. It is when we say held constant, this the interpretation, what we really want to say is that it is the impact of this on this, everything else having been partialed out. It is also called the partialing out interpretation of regressions. Okay. This is basically everything has been removed. Yes. I am sorry, Frisch-Von theorem. Just look partialing out interpretation, you will find it. Okay. Everyone clear about this? Is a very important step in understanding anything to do with policy or how to use regressions and so on and so forth. Okay. So, though I am teaching you a course on trade, this is the most important thing you should, because we will be using regressions all the time. All right. Okay. Now, we have, so as I said, we have put caste there, right, but there was nothing that stopped us from putting many more things there, right, and the interpretation would be the same. Instead of predicting wages with just caste, we would predict wages with caste and everything else. Similarly, we would predict years of schooling with caste and everything else. We would take the whatever is not predicted, and if you run the regression, that would be the same as running a multivariate regression with years of schooling, caste and everything else. You would get exactly the same answer. Okay. Now, there is something here that we have not removed, right. So, the impact of caste we have removed by this step, right. You give me other things that you can measure, I can also remove that by doing exactly the same process. Yeah.
Same thing can be said about C also.
Huh?
The same thing can be said about C also. Like C is the
Exactly. By the way, just by extension, what is the interpretation of C? The C is the interpretation of caste, removing the impact of years of education. Exactly, you can do, it is the same argument, there is nothing special about B. The same is true for every coefficient in the regression. Okay. But of course, the mechanical process would be different. So, if you had to get the coefficient for caste, first you would have to run the years of the wages on years of schooling, then remove that, and you would get some residual. Then you would have to run a regression of caste on years of schooling, remove some residual, then regress one on the other, and you will get exactly the same coefficient as C. Okay. All right. What have we not? So, remember what is the idea of partialing out? We want to compare between likes, right. The idea that we want to look at the impact within a caste is because we feel that caste has its own independent impact. So, we want to, when we compare two people with two levels of education, we want to have a comparison like that box, right. We want to compare likes to likes, same kind of people to same kind of people. Okay. Now, by throwing in all the other regressors like caste, income, mother's education, whatever, we are trying to make people similar by removing the impact of those things. Okay. Now, there is still something that remains unresolved in this particular specification, right. So, we have compared people in terms of things that we can observe, caste, income, mother's education, so on and so forth. But is that enough? Exactly. Human being is not just what you observe about him, or a firm is not just what you observe about the firm. there is also something that we don't observe about the firm, right? Can we use the same logic here to the part that that we cannot observe? Remember what the steps were? We were regressing something, years of education on caste. We observe caste, we observe years of education in data. Yeah, we can run that regression. Right? Can we do the same thing to unobservables? No, because by definition unobservable is unobservable. How will you run that regression? Right? How will you run a regression of years of education on the unobservable? So, पता ही नहीं है क्या है. By definition is something that you don't know. Okay? So, this is a process that this is this mechanical process you cannot follow when it comes to unobservables. Right? But now we are all very apprehensive, because we know that even after controlling for everything that I can see about you, there are things that I cannot see about you. Typically most data sets will not have that, not have enough to cover everything. Right? So, how do we still make statements that we are comparing likes to likes? What do you think? What is the most important assumption that is made when you run a regression? Huh? What does that mean? It is true that you get it as an outcome of something, but what does it mean? Just let her complete a thought. Actually, it's even more fundamental than least squares, but it is true. You can use it in least squares too. So, what's the intuition behind expected value of 2 being 0? Huh. But how does it, that may be a true statement, but how does it that has anything to do with this fundamental problem we have, right? My fundamental problem is that when I am comparing two people with different years of education, right, there is something that is unobserved about you that is also different, right? So, when I say it is because of years of education, so she has more years of education than him, I am looking at both the wages, but now I am scared that she has something unobserved that I do not have data for, that is different for her than you. And then when I see the difference in wages, I think it is because of years of education, but it is not, it is because of basically that difference between you people that I cannot observe. That is the fundamental problem. So, what is the assumption that gets rid of that? Huh? Errors are? What does that mean?
So the unobservable that is responsible for different wages for the two individuals, they are different. I might have some different unobservable.
Yeah, but independent basically means that if I look at his, if I for some reason had some idea about his unobservables, I would learn something about, or I will not be able to learn something about hers because they are independent. How will that? Exactly. Right. So, it must be that when I see people who are more educated, right, that systematically there should not be something else at the same time that moves together with the years of schooling, right. So, it could be that there are observables about you, that is fine, but it should not systematically correlate with your years of schooling, right. So, it should not be that on an average when I see people who are more educated, that at the same time on an average something else that I do not observe also is higher or lower, right. Because if it is so, then I cannot tell you whether it is because of schooling or because of that other thing that is moving systematically at the same time. Everyone clear? Right. So, looking at the difference between both of you would be valid if there may be something different about you, but does not really correlate with your years of education. Okay. It is only then that what I can say has a true causal interpretation. Okay. So, two things. One, I remove the impact of everything I can observe different about you by controlling for it in a regression, right, and with that interpretation, right. And second, that whatever I cannot observe about you, of course, I can never check because it is all data driven. I mean, there is no data for it, but I assume that those have no systematic correlation with the invariable of interest, years of schooling. Okay. Now, of course, if the world only relied on assumption, then we would not go very far, because you can say कि नहीं है, I can say कि हाँ है, right? And scientific discourses by this construction extremely, no one believes anyone. Okay, that's the way science works. You have to be critical about everything, right? So it is not possible for anyone to convince the other person that, look, there is something unobservable, but nahi hai yaar. I hope, I am telling you, this does not work in scientific discourses, right? We want this assumption though, but we can assume it, but then we have to defend it in some way, okay? And so any good empirical work requires an idea that you have to be able to get an experimental design, okay? Something that kind of ensures that in fact there is no correlation with unobservables and the variable of choice. Okay. So, typically, since you are in Bihar, Bihar has been the hotbed for many interventions. How do these interventions work which kind of ensure that you get this condition to be true? Say you are God, right? But it should not systematically correlate with your years of schooling, right? So it should not be that on an average, when I see people who are more educated, that at the same time on an average something else that I don't observe also is higher or lower, right? Because if it's so, then I cannot tell you whether it's because of schooling or because of that other thing that is moving systematically at the same time. Everyone clear? Right? So, looking at the difference between both of you would be valid if there may be something different about you, but doesn't really correlate with your years of education. Okay? It's only then that what I can say has a true causal interpretation. Okay? So, two things. One, I remove the impact of everything I can observe different about you by controlling for it in a regression, right, and with that interpretation, right. And second, that whatever I cannot observe about you, of course I can never check because it's all data driven. I mean, there is no data for it, but I assume that those have no systematic correlation with the invariable of interest, years of schooling. Okay. Now, of course, if the world only relied on assumption, then we would not go very far, because you can say कि नहीं है, I can say कि हाँ है, right? And scientific discourses by this construction extremely, no one believes anyone. Okay, that's the way science works. You have to be critical about everything, right? So it is not possible for anyone to convince the other person that, look, there is something unobservable, but nahi hai yaar. I hope, I am telling you, this does not work in scientific discourses, right? We want this assumption though, but we can assume it, but then we have to defend it in some way, okay? And so any good empirical work requires an idea that you have to be able to get an experimental design, okay? Something that kind of ensures that in fact there is no correlation with unobservables and the variable of choice. Okay. So, typically, since you are in Bihar, Bihar has been the hotbed for many interventions. How do these interventions work which kind of ensure that you get this condition to be true? Say you are God, right? You are unobservable. You notice how I still keep God to be not know everything. There is some part about you that God doesn't know, right? But you have extreme power. You can do anything you want. How would you do it? Right? So we want to do something which will allow you to run that regression, and yet you will be more or less assured that the years of education will have nothing to do with the unobserved part about you. Choose those. How will we choose? I mean, he's kind of, it's wrong on many levels, but it's a good starting point. Yeah. One way to, what's an RCT? Yeah, You want to, that's the great thing about RCT. You need to know very little about it. The requirements, technical requirements to understand an RCT are very, very simple. Anyone? How do we treat? How do we decide who's to be treated? What does the word what does the expression RCT stand for? It means we list all the people and then let the computer choose. Right? It means that we get two groups. So what does randomization do for us? If the computer chooses, what happens? Everyone has the same probability of being chosen, right? Now you observe that it's not necessary that you have an homogeneous population either. You can have all kinds of people. What should be the requirement at the end? That on an average, people who are treated are no different from people who are not treated, right? So it doesn't require homogeneity. Of course, if you get more homogeneity to begin with, it's more likely that you will get it, but it does not require it per se. Okay? All you require is the two groups look the same at the end of it, right? But the principle does something more. Because the computer chooses it and you don't choose it, it's not likely that your being treated has anything to do with this unobserved part about you. Remember, this is something you can never check, right? So what the principle of randomization, all that's doing for you is because the decision on whether you should be part of this group or that part of that group, since it does not depend on anything about you, it's likely that it does not depend on this unobserved part about you. Okay? So when I see, so I do some maybe randomization, give you some schooling voucher, something like that. In a year, your education goes up, and this group, maybe I do it for this is not randomization because left and right. So I'm sure there are preferences which make one person left and sit on the right, which may have something to do with your wages, right? But let's say I kind of have some group here which has been chosen for a voucher, another group has not been. I look at your wages, then if I see a difference, that difference is unlikely to be driven by unobserved part about you at the group level, because whether you got the voucher or not, that had nothing to do with you as a person. You were just lucky, right, that you just got into the group because the computer chose you in a certain way, right. So randomization is a way to give you a regression or an analysis where unobservable things about you do not matter, yeah, at the the level of a group. Is it even clear? So remember, if I just took your data right now and looked at years of education and I control for everything I see about you, you are still किसी कोई मेहनती है, कोई बहुत diligent worker है, कोई sincere है, कोई whatever, and I have no data on that, and there is no way I will ever get data on that, right. We know that matters for schooling outcomes, we know that matters for wage outcomes, right. So to remove that impact would be very tough because I would never have data on it. But by an experiment that I just told you, your being part of the voucher scheme has nothing to do with whether you are mehnati or you are diligent or whatever. So it's completely uncorrelated in principle, right. And we hope that if something is in principle seems to be uncorrelated with all these other things about you that I don't see, it must be the case. You are hoping that it will be the case in the end that that's true overall. Okay? So your results are not driven by unobservable things about you. Okay? But RCT is only one kind of design. Okay? It's not the only kind of design that gives you that. In effect, what you need. So what is the most fundamental objects in the data that actually give you this B? So let's say that, so for example, if I ran this regression for you guys here, right, would I get, what kind of results do you expect for B? Positive, okay. Do you think it will be significant? Everyone knows what significance is. Do you think it will be significant? Significant means that it's estimated with some precision. Why not? Why not? Okay. Relationship between years of education and wages for the population, right, of India. I have a sample, you guys. Okay. I run this regression. I get some B. You are contending it's positive. Let's hope it's positive. Okay. But I find it's very imprecise. No, it has a very. Maybe it's insignificant. That means insignificant. मतलब B has such a B इतना low confidence है तुम्हें, इतना imprecise है कि वो zero भी हो सकता है. Right? Statistics में we always check. Why do you think I'm giving you the answer? So now why would you think it should be so? I'm controlling for all the other factors. Let's say I do this, this. So let's say this is not the problem anymore. That the error term, for some reason, none of you are connected. Your parents are not connected. Your wages, epsilon is not correlated. So that is a separate problem. We have talked about it. That's done. Now we have come to the fact that your years of education have nothing to do with anything unobserved about you. Okay. Let's say that let's say that there is some relationship, right, which is so it goes from, so there is a, it's true that your wages will be higher but your education is higher, but maybe think of a linear line, that there is a linear relationship between education and wages, and I am observing only people at the top. They have higher wages, but the relationship is equally true or maybe true. Right. So wage जैसे बढ़, education जैसे बढ़ता है, wage बढ़ता है, but let's say that is a straight line, and at the end of it, you're observing only you guys, and most of you are PhDs or something like that. So at the top, I'm only observing top, but I'm observing that line. ऐसा नहीं है कि कहीं और observe कर रहा हूँ. Tomorrow, let's say we hold IGC summer schools every day. I mean, different groups every day, so I get different observations. Yeah, so I'm saying it's not, I'm giving you the answer. I'm saying it's not significant. That means that the beta you get, so the beta you get is not contaminated by epsilon. So that problem I'm giving you. कि मैंने ऐसा कुछ किया है कि I have got the, by the way, you guys know what that term is when B is not contaminated by the error term. It's called consistency. Estimator is consistent. Okay. So I'm giving you that. Now the question is, I am running this regression और positive भी आ रहा है, पर zero आ रहा है. Significant मतलब significant जब कर रहे हो तो test तो बोल रहा है कि वो zero भी हो सकता है, right? और in confidence interval draw कर रहे हो तो B तो मतलब is going from minus to positive, big interval, मतलब कुछ भी हो सकता है. Exactly. So what is the implication of that? I am telling you the relationship more or less is true. I mean, it's like, so it's not a line, but a little bit like that, but if I could get this slope, बहुत गलत नहीं होगा मैं. So the idea is that you guys are here, right? There are also people who are illiterate, so उसका data नहीं है मेरे पास. So the problem is, agnostic is right in the sense that the problem comes from the fact that all of you have very close education construction. You are at the IGC workshop, right? So you are all somewhere here. What is the implication? So I'm telling you also the answer. Because of this, there is basically you get an insignificant coefficient. Matlab, when you estimate this confidence interval is so large that it could even go down, near zero. बहुत बड़ा है, so it's insignificant. मतलब zero भी हो सकता है. Zero is also part of the set.
Standard error is too large.
Yeah, obviously insignificant है, मतलब standard error बहुत large है. Why is standard error large? There is no selection bias. I'm telling you, it's all selected. We are observing only part of the sample. I mean, it's selection bias नहीं है. Selection is based on the fact that you are highly educated, so I'm observing one part of the sample. Yeah, so the answer, we are converging towards the right answer. Of course, the standard interval is large, means standard error of beta is large. Why is the standard error of beta large?
The data is
nahi. Just think about what matters for, you know, when you come to these things, always think about the formulas that you learned but never cared about. You know, you will realize where they all come in. What determines the variance of beta in an Oilless regression?
The mean and the individual coefficient are almost same coming together.
Two variable model में what's the variance? What does it depend on?
X minus x bar pi minus pi bar.
X minus x bar whole square. आता है कि नहीं नीचे? Sigma.
Denominator.
The variance of x. What is happening to the variance of x here?
That is minimum. X minus x.
बहुत कम है. What does that mean about the standard error?
That is in flattening.
Right. Whenever in data the variance of x is very low, immediately you don't have to tell the econometrics of it. The econometrics of it is trying to find the relationship over the whole range of x. As soon as you give it only a particular level of x and with so little variability, it immediately will give you an answer that I can give you a beta, it looks positive, but you know तुमने दिया है छोटा वाला part, variance बहुत कम है. इसका तुम अगर interpret करना चाहो to, you know, to all other parts of x, we are not so sure. Okay, that means that beta is very large, right? Yeah. So that's how, you know, the regression is set up, so that you require to estimate something, and with some precision you always require some variability of x. You need all kinds of people, right, to say something about the population, because the population has all kinds of people, right. So if you have very homogeneous group of people, then typically you are going to get very low variability. If the world is heterogeneous but you give the sample only homogeneous people, then the answer will be yes, you will get some coefficient, but वो मतलब you don't learn that much. Low precision मतलब I did some exercise, but I really did not learn that much about it in terms of the population, because you just gave me one small segment of population. Okay, this particular property of an estimator is called consistency है कि when n tends to infinity and b goes to beta comes from the fact that if you give me the true data, everyone, then because x and epsilon are not correlated, इतना लंबा नहीं, it's called efficiency. An estimator is efficient if its standard error, if its variance is low, right? So there are two properties we want of estimation. We want first that when you estimate particular influence of a variable, that is in fact the influence of that variable only, and not something else that either is in the system that we can observe or things that we cannot observe, right? That was property is called consistency. The second property we want is अच्छा ये तो हो गया, फिर तुमने मुझे कुछ data दिया, but at the end of it, if you only give me such things that variance of x is very low, then I cannot say a lot about the population, right? So we want to look at methods which are efficient, which means have low variance. Okay, these two properties characterize what a good empirical work is. So there are often ways that you can create experiments where you get similar kind of people, where consistency is not a worry, because by construction you have got similar kind of people, but then there is a trade-off, and the trade-off is by creating these similar kind of people, you have restricted yourself to such a small group that then talking about the world becomes very different. Okay, that is reflected in this variance of epsilon of beta. Okay, so always whenever we want to do anything which is this particular field is called causal work. Anytime we want to do causal work, we always worry about these two things. It's not great to have a setup which will give you consistent estimate, but वो हमेशा answer आता है कि insignificant है. उससे we can't go very far. Okay, and that has to do with the efficiency of the estimator. Okay, so with these two things in mind, right, keep these various parts of the story that I have told you in mind. Okay, these are the fundamental problems that we want to address whenever we want to do empirical work. Okay, now empirical work generally in India can be divided into, as I said, two parts. One, we want to know pure correlations or partial correlations, right? These are descriptions of the world, right? If you observe people with these characteristics, they tend to have something more or less. इनका weight ज़्यादा होता है, इनका health खराब होता है, education कम होता है, so and so forth, right? There is nothing wrong in doing that kind of work too, because in fact we don't know, people have not done enough to know what are interesting kind of correlations that exist in society. But to be able to move from there to policy work, often you will need to have a causal framework, which is this kind of a design, right, which is basically going to give you some causal interpretation, right. Now, one of the things that I want you to get out of is this idea that you can get away from causality by controlling for more and more variables, okay. So typically when you are starting off, you just think that मेरे में तो 50 मेरे variable हैं, control, that's enough. But if you think that all the 50 variables are enough, then why do you still have R squares of 0.2, 0.3, मतलब 70% of the variation of y you cannot explain, right. Typically most regressions will have, apart from time series, which is slightly different, you will basically have R squares of 0.2, 0.3. 70% of y तुम explain नहीं कर पा रहे हो, you're not able to explain 70%, right. So obviously it has many things out there which you don't have data for, right. So even after 50 variables, if you're then just controlling for variables is a non-starter, okay. It helps, of course it helps get rid of some stuff, but you still need to have an empirical design to write a tight paper, okay. But as I said, I just want to, before I go to what I was planning to do initially, I want to tell you is that you can do interesting descriptive work, except that don't claim that it's causal, right. The problem is not in doing descriptive work. The problem is that when we do descriptive work, we start saying this causes that, this causes that. That is the one that people challenge. People don't challenge the fact that if you have certain variables and you run a regression, you get coefficients, you say, well, this is positively correlated with this thing, I observe this, these are interesting correlations. Why is it people of this kind of background are going to give you this kind of wages, this kind of sanitation, this kind of health? Why? Right? And that's interesting questions, and that lead to thousands of interesting things that you can work on, right. But to say that that variable causes this variable requires more effort, right. And people are accepting if you write papers which are interesting descriptive papers, but don't claim causality. Okay. Yeah.
So you said that 50 variables, and so you have no R square. You cannot really claim that anything's happening. Say I have my R squared is 80%.
Yeah.
Or 70%. Even then, is it? It's
You still have
problematic,
20%.
right?
You still have 20%.
So I mean, to claim impact is still problematic, right?
So it's not a question. See, what does R squared 70% tell you? It tells you that you have many variables which are important for y in your regression, right? But you still have some things that are not important.
Right.
But now the next question is, how correlated are these particular variables to the x of interest, right? If they are highly correlated, yeah, you still have the same problem, okay? Because there are two things, right? The low R square is just telling you that or high R square is telling you there are lesser number of things that you don't have data for, right? But the second thing, it could be that there are very few things that you don't account for, but they are highly correlated with the x of interest. Yeah? So then what you estimate as the impact of x is actually the estimate. So these are not convincing arguments, right? These are like halfway there. Though there are some tests which try to rely on these kind of descriptives to fight the case, but it's still on weak grounds, okay. So you could have very high R squares, you could have only one variable in the error term you cannot observe, but it's almost the same as the variable you are interested in terms of correlation. Correlation is 0.9. So you have the same problem, then you are giving the impact of this variable that you cannot observe, right. So that problem remains, okay. All right. Now where I want you to move now to the next step is that, having appreciated all these problems, when you do micro work, you will see that a lot of people will talk about RCTs and so forth. There are some designs which in fact do a decent job, but when you are talking about macro things like trade, like industry, like health, like things like NCDs, cancer ho raha hai, diabetes ho raha hai, You cannot randomize people cancer or randomize people this. You cannot randomize tariffs. You cannot randomize, these are not possible because these are not small like let's go to 50 villages and do it. These are macro things, right? And these macro things cannot be randomized, right? So as I said, you need variation in X, right? This variation in X in micro work can often come from experiments where you like give something to someone and their years of schooling change, their health change and stuff like that. But you cannot change the productivity of firms by doing a randomized controlled trial typically. You cannot, you cannot change the GDP by running a randomization, right? So anything that has to do with anything macro, which is basically what I'm going to talk about, or firms, firms will not agree to your randomization. Household ko fir bhi maan jayega ki chalo you are part of group. You go and say ki yeah, all listed firms of India, acha randomize kar denge aapko tax collection mein. They'll say no, I'm sorry, not agreeing to this kind of a randomization thing. So when you study firms, when you study macroeconomic concepts, the concern is still the same, but the way out, you cannot run these experiments that you think about in micro. Okay, so you have to think about other ways to tackle the same problem. So what I'm going to do today, while I'm going to talk about trade, IO, and stuff like that, keep this in mind. The kind of things we will say are relevant for doing research for at the level much higher than micro units, right? And when it comes to firm level, sometimes you can randomize across firms if it's management style, stuff like that. People have done that in Pakistan, for example. But typically firms will not agree to small randomizations. So you will have to talk about, aggregate some strategy or something that generates, variation of X that has nothing to do with epsilon, right? Or you have to provide some evidence that that's not the case. Okay. So with that in mind, so we are going to start off what I intended to do. Not small like let's go to 50 villages and do it. These are macro things, right? And these macro things cannot be randomized, right? So as I said, you need variation in X, right? This variation in X in micro work can often come from experiments where you like give something to someone and their years of schooling change, their health change and stuff like that. But you cannot change the productivity of firms by doing a randomized controlled trial typically. You cannot, you cannot change the GDP by running a randomization, right? So anything that has to do with anything macro, which is basically what I'm going to talk about, or firms, firms will not agree to your randomization. Household ko fir bhi maan jayega ki chalo you are part of group. You go and say ki yeah, all listed firms of India, acha randomize kar denge aapko tax collection mein. They'll say no, I'm sorry, not agreeing to this kind of a randomization thing. So when you study firms, when you study macroeconomic concepts, the concern is still the same, but the way out, you cannot run these experiments that you think about in micro. Okay, so you have to think about other ways to tackle the same problem. So what I'm going to do today, while I'm going to talk about trade, IO, and stuff like that, keep this in mind. The kind of things we will say are relevant for doing research for at the level much higher than micro units, right? And when it comes to firm level, sometimes you can randomize across firms if it's management style, stuff like that. People have done that in Pakistan, for example. But typically firms will not agree to small randomizations. So you will have to talk about, aggregate some strategy or something that generates, variation of X that has nothing to do with epsilon, right? Or you have to provide some evidence that that's not the case. Okay. So with that in mind, so we are going to start off what I intended to do. I'm interested only in what is the impact of X, and for some reason we have been able to find an experiment where you are 100% guaranteed, or nothing is 100%, but high probability that X does not correlate with epsilon, then your answers, the beta in front of X, is completely valid for making the statement that when X changes ceteris paribus, Y changes by B. Okay? But at the same time, it may well be the case that the R square is very low, so it does not really have that much prediction power. But your job in this analysis is not to predict. You are not trying to predict Y. You are trying to say if I change x, what will happen to y? The nature of the question is very different, right? And those who do work on the field, especially on social issues, will often find this a very hard idea to get across to people who work in sociology, in policy circles, that whenever people start to think about, oh, but there is emotional thing about people, how people not everyone is rational, people think differently. That's all true, and that's why we have epsilons, because we know that outside our variables there are many things that matter for each outcome, right? But that's a world where you're trying to explain why a particular y takes a particular value. Okay, this is not always our aim. Our aim is sometimes just to say that if I was government and I were to change something, if I were to change a particular x, what would be the impact on y, right? And for that, all I need is an empirical exercise which helps me estimate that particular x, right? Now, the only reason why not having many variables in your regression is a problem is this experiment is very hard to come by, right? It's very hard to design an experiment where x changes and you are damn sure that x changes and nothing else changes systematically at the same time, right? And so when you get a regression with very few variables, then there are so many things that are not controlled for, it's very likely that they also correlate with x. Okay? So if you see a typical randomized control trial, you'll see that regressions are run with just one variable. It's just the treatment effect, the y and the treatment effect, and that's it. They have very low R squares, but they don't care about R squares, because they just want to say, well, I was able to give this particular treatment, it was done in a way that it doesn't correlate with epsilon, this is the impact of the treatment. It's a limited statement, but that's what the experiment is set for, right? But you cannot take the RCT and say, I will tell you now the story of why, right? Why this particular y takes this value. It's not aimed for that exercise. It's not a prediction exercise, right? It's an exercise to look at changes, impact of changes. Okay? So these two things are important to keep in mind. All right. So with this, I'm going to talk today about firms. And as I said, because we can't do these RCTs and so on and so forth, we need to think about various concerns which are very similar in nature. Okay? Now, in addition to what we have talked about, one nice thing about working on firms is that there are particular functional forms when it comes to firms that are more validated. Okay? So here's a Cobb-Douglas production function. It has been estimated 1,000,000 times over. Okay? People have found for various things it does a great job. Okay? Now, could I do this if I were working on consumer behavior? That utility function is a Cobb-Douglas? It's very difficult, because utility is a very abstract concept, right? There is no way I can write down a utility function and say ki ye to tumhara to Cobb-Douglas hi hai. It is not possible, right? But whereas with firms, since you can observe the production processes and people have been estimating them for long, people have more confidence in production functions. Okay? Now, as I said, one of the classical production functions is the Cobb-Douglas, which doesn't do a bad job. But having said that, I must point out that there are many production functions, and you can kind of, there are Leontief and so on and so forth, which do a much better job for particular production processes. Nothing that I am saying is so specific to, particular production function, but this production function has a nice form which helps us get to the deeper ideas of what we want to do. Okay? So one of the concerns that people have everywhere is firm productivity. Okay? Especially in less developed countries, because we always worry that our firms are inefficient in some way. So to understand something about firm productivity, this is basically linked to estimation of production functions. Okay? So this is the literature in itself, and for many, many years, people have been estimating production functions. So for example, as I said, the Cobb-Douglas production function for the ith firm at time t, so I and t, is something like that, where L is given by, so Y is a measure of output, L is labor, K is capital, M is some intermediate input like raw material, energy, so on and so forth. A is total factor productivity, and typically when we talk about productivity of firms, we are talking about this A. Okay? How productive is this firm? What does it do? This productivity basically increases all factors, marginal products simultaneously, right? So, a unit of labor, a unit of capital gives you more output for a particular firm if its A is higher. So, this is just a more efficient firm. Okay. So, I am going to assume throughout that this A in some sense increases productivity of everything, but you can write down production functions where A is it raises the productivity of labor, but not as much capital, so on and so forth. So, it can be biased towards particular inputs, but let us not get into that. So, it is just that it is more general than what it seems here. Right here it just says that a firm with a higher A basically is productive because the marginal products of all those factors is multiplicative in A. Okay. So, one small note if you are interested in doing this kind of work is that often data, so this is what we want to estimate, right, and we in particular we want to estimate A, the productivity of firms. Okay. We have data on Y, L, K, M, right, and we want to estimate A. Now, and of course, this is not an exact relationship. Every firm, if you put L, K, M, will vary a bit. It's not that every firm produces the same thing, but we'll talk about that. So, there's some variability across firms for sure. So, often data is available for real value added. So, we want Y, the value of real output, but what we usually get is value added, which is the it's the output or sales net of intermediate inputs, right. People remove electricity cost and all the intermediate costs. Now, the problem in doing that is that once you write down a production function, you have to be very serious about it. Okay. You cannot just say ki just for motivation hai. You cannot do that. So, if I use Y in the product if I use value added instead of Y in the production function, what am I assuming? I am assuming that the production function is additively separable in price and intermediate inputs. Matlab, you can divide the production function into L K से क्या आता है and separately from M से क्या आता है, so that you can subtract out M from the left hand side and you can do it. Okay. So, this requires a very particular stylized form of what a production function is. Okay. So, whenever you get value added, remember that you can put it, you can estimate it, but you are assuming something more. It is not as general as the production function you saw there. Okay. Of course, if you use value added and then run a regression on L, K and M, that is garbage because already you have taken out the impact of M, right. So, you cannot look at the coefficient of the intermediate input. These are from various theses that I have examined over the years. I have seen people do these kind of things. So, just letting you know. So, additive separability has a strong assumption because the choice of primary, so what are you doing? You are taking the sales or output, subtracting out all the cost of inputs, intermediate inputs, and running a regression on L and K. Matlab, if everything else is the same, if you increase L, what will happen to this output? Okay. But the choice of primary inputs is in general not independent of intermediate input prices, right. So, when you are saying you are subtracting it out, but L and M are determined at the same time, determining electricity ka kya cost hoga, will determine how much you will produce, how much electricity you want, will determine how many workers you hire. So, by doing value added, you are assuming that intermediate ka problem pehle solve ho gaya hai. I subtract it out, now I think ki worker zyada hire karenge to kya hone wala hai, and so on and so forth, right. But that is a vacuous argument because L and M are decided. So, as a firm you decide, acha, we need to run the machines for this long, I need this much electricity, I need this many workers. You cannot separate out the two decisions so easily. Okay. So, if you do that, and people do what they can sometimes, if you do not have data for Y, all this lecture is no use, so you still have to write something. So, you can do it, but just remember this is a strong assumption. It is okay in empirical work to claim something as long as your assumption is clear, but of course, the acceptability of it will be determined on whether you can defend your assumption or people believe your assumption. Your work is only as good as the assumption that you have made. Okay. So, the diktat from there is try to use data on physical output as much as possible or deflated plant sales. Again, the problem with deflated plant sales is that once you take sales, you need to get output, you need to divide by appropriate price. Typically we use some sort of a price index to do that, but if you use aggregate product prices, this can lead to bias, because of course different firms produce different things. So Sony TV ka or LG ka, you look at sales, look at the average price of television, divide the sales by that particular average price. That's not correct, because Sony produces much higher quality stuff. So its actual implicit price is much higher, right, than that of LG. So that's an easier example, because we of course know what Sony prices are. But at the plant level, for many products, that's impossible to get. Okay? So try to use data on physical output as much as possible, so that you are as honest to this production function estimation as possible. Okay? So what do we do with that production function? Well, we can take logs, right? And that's one nice thing about working with firms, is that you can go from a theorem. They take this even more seriously. So if you take the logs on both sides, you are going to get beta times L plus gamma times K plus delta times M plus UI. Okay? What is UI? It's just a log of A. Okay? So this is one of those things where if you estimate beta, gamma, delta, right, consistently, that means that you don't have any biases there. Then if you subtract out those from Y, you will get the U, and the U is the average productivity. Okay? You may need some more assumptions to do with the error terms, but you will get log of A. Okay? So it's a nice, this kind of going from here to empirical work, where you take the utility function the production function very seriously and actually try to estimate it, is called structural work. So whenever you see people say they have done some structural estimation, it means that they have taken a particular utility or a production function, and then it's just not motivation. They have taken it and then taken it to this empirical counterpart, and they have estimated it. Okay? So y log of A, y log of K, why not just run a regression of y on L and K? Because what you then get as coefficient does not map onto this production function. Okay? Whereas if you take logs and you run this estimation, then what you get as coefficients are in fact beta, gamma, and delta there. Okay? So whenever you do structural estimation, which is basically inspired by a particular production function, you can get parameters which are much deeper. Deeper means that you actually, so once I know beta, gamma, delta, I know A, I know how firms produce. Now I can try my favorite experiment, you can run simulations, because it's as if I know the firm. I know what the firm, how it firm operates, right? So structural estimation has this advantage that once you get parameters, they have deeper interpretations. Okay? Now, how do I estimate this? Suppose I run an ordinary least square regression, and so basically I have all plant level data or firm level data, and my regressors are L and K. So I run this regression. When will I get consistent beta and gammas? Well, I'll get consistent beta and gammas when there is nothing unobserved about these firms that correlate with L or correlate with K, right? So I need the covariance of L and U to be 0. I need the covariance of K and U to be 0, just like what we had talked about before the break. Is that true here? Yeah? देखो ये देखो और ये देखो. Natural, visual illusions are always, be wary of that. Look at this carefully and look at this. M is absent. So when will this be consistent estimation? When will ignoring M not matter? So not matter matlab what you estimate as beta and gamma are truly beta and the true beta and gamma. When will that be true? अच्छा M अगर यहाँ नहीं लिखा हुआ तो M कहाँ है? Where is M? In the U. So I need these two conditions. So what must be true? Well, the correlation of M and U is not 0 by construction, because here m was there, we know the production function is like that, but now m is not there, matlab m iske andar ghus gaya hai. So m and u is basically some part of u is m. So when would this be consistent estimators of beta and gamma? Multicollinearity, just forget this term. I don't know where you guys get this. Multicollinearity is collinearity between two variables, right? I mean, perfect collinearity between two variables. Forget about that. Unless you are making a big mistake somewhere, you'll never get it. What must be true? The covariance of L and U must be 0, K and U must be 0. अब U में वो तो नहीं है ही नहीं, वो तो because M इधर बैठा हुआ है. So, हाँ, M is part of U. So वो तो we know that they are correlated. So when will the estimation exercise still be valid? Under what assumption? मतलब मैं M के बिना M यहाँ अंदर है, I still estimated and I claim that no, my beta and gamma are fine. When will that be the case? It will be the case when M and L are uncorrelated and M and K are uncorrelated. So your labor and your capital choice have no connection with the choice of intermediate inputs. Okay. So if you can make a strong case for that, using something about the firm, how it works, that electricity to pehle se diya hua hai, it comes from somewhere else, we don't control it. Like water pump, if you go to UP, the amount of time you get water is not determined by choice. वो तो चलता ही रहता है, आता है जब चलता रहता है. You'll see fields inundated, right? So people keep it on. So it's not like there's a labor that they decide how much based on the water. Well, now it's getting to be more important because of groundwater, but in general. So there are, I'm telling you because there are certain industries, certain situations where you can make an assumption and get away with it if you can give a convincing story with it, right? So if you didn't have M, but you were able to convince that L and K are uncorrelated with M, even if you don't have data on M, you could run this regression. Okay. So as I said, choice of K and L depends on the unobserved M. Okay. Now the main problem in, even if you can do that, you can estimate beta and gamma properly, right? But remember, beta and gamma is only one, is a step. What are you really interested in? You are interested in this A, this log of A. ठीक है? But if you estimate this properly, what will you be? You will be delta times M, जिसके बारे में कोई data नहीं है, and the TFP. So even if you can get beta and L, you cannot get the productivity. Okay. So this is basically called a classic omitted variable problem. There's a variable that matters, but you don't have data for it, and so any residual which you get from Oilless regression is inconsistent. So basically it means it's not the TFP. Okay. Okay. So okay, let's forget that. So problem 2. Suppose we have data for M. So this problem is not there. Now there are some more kind of realistic problems. These are realistic problems one has to think about. So at least a part of the TFP will be observed by the firm at a point in time early enough so as to allow the firm to change the input decision. Firm को पता है कि मुझे मेरा सामने contract आने वाला है. I'm going to get a big order. Or firm knows there will be a technological upgrade. हमारा machine आने वाला है, right? As an econometrician, you have no idea what it is. So you are just getting data. Okay. So of course, how much it hires of L, K, and M will depend on this part of TFP, the productivity, that the firm can see because it's making decisions. It knows how smart or good it is, but you cannot because you are just a guy who has just got data. Okay. So then the error term TFP of the production function is expected to influence the choice of factor inputs. So remember, again we are back to this problem that we have this equation U, something about the U the firm knows, and it determines M, K, and L based on that, right? You as an econometrician don't know, the empiricists don't know this, but you know that the firm can do that. So you know that U, M, and K and L, they are all correlated. So again what you get as K, L, and M will be inconsistent. You will not meet that condition, right? So to write it more to see this, let us split the error term u into two parts. So, y will become beta times L plus gamma times k plus delta times m plus some part that the firm can see and decides m, k and L accordingly, and of course, there is some part which is idiosyncratic stochastic error. Okay. So, if omega is observed by the firm early enough to affect input choices, but omega is unobserved to the economist, the conditions for consistency are not met. Okay. So, you can get all kinds of input data, but you are not the firm. The firm knows more than you as an empirical researcher. If there is something unobserved about the firm that the firm can see and decides its inputs accordingly, and you cannot see, then what you get if you run the regression is inconsistent. Okay. So, there are some standard remedies for this. One remedy is called fixed effects estimation. You guys know what fixed effects estimation is? Okay, we'll do it if you don't. It's a particular context, but of course, it's a much more general method. So, let's say if there's a part of TFP that influences, that's omega, that's specific to the firm and is invariant over time. मतलब firm को पता है कि हम तो बड़े we are good. तुम्हारे लिए it's some data point. So, firm knows it's good, firm decides its inputs accordingly. You as an econometrician have no idea, it's some firm ID number in your data set, right. So, let's say that this is something that is not revealed, it's not new information that's revealed every period. Firm is good all throughout, it knows it, you don't know it, but it knows it. Okay. So, therefore, omega IT is just omega I, means each firm has some part that it knows, it's good, it doesn't vary over time, but you as an econometrician have no idea what it is. Okay. So, then if that is so, then notice that if I were to write this down, so I have longitudinal data and I must be doing a T, that's beta times LIT plus gamma times KIT plus delta times MIT plus something I don't observe, but the firm observes omega I plus some idiosyncratic error. Okay. Now, as it turns out, I have data for this firm in another year also, let us say next year. So, yi t plus 1 equal to beta li t plus 1 plus gamma ki t plus 1 plus delta mi t plus 1 plus omega I plus epsilon I t plus 1. ठीक है? So now I use a trick. I say, okay, let's subtract this. So if I subtract this, then I'll get beta LIT plus 1 minus LIT, KIT plus 1 minus KIT, MIT plus 1 minus MIT. But since how smart the firm is, that's the same over time, that cancels out. Okay? And epsilon IT plus 1 minus epsilon, the EIT plus 1 minus EIT. Okay? So now if I were to do a simple Oilless regression of the changes on changes, you observe that omega I, which is the problematic variable, right, is differenced out. Okay? This has got a fixed effects regression because I'm assuming that there is something unobserved omega I that is fixed over time. Okay? It's omega I every period. If omega I changed every period, then this method will not work. Okay? It only works under this condition.
Procedure to estimate like WI. This is the first step where you eliminate the unobserved trend.
Yeah.
Then the second in the pattern you all the slope coefficient.
Yeah.
The second step you try to estimate WI.
We don't have to estimate WI. Once we estimate this, right?
Second step, because in the panel fixed effect, this is the first step towards estimating WI. Na?
Which what is it? I don't see a WI. So this one. Yeah. So omega I will come as a residual, right? So remember that once you estimate this, you will get beta, gamma, delta, right? They are what you require to estimate, this particular expression, right? Right? If you give me beta, gamma and delta and you have output, you subtract it out, you are going to get omega I plus some idiosyncratic error term. Okay. Now, the idea is that if you average that over the sample, coming to your assumption, the average of this EIT, this is 0. So, on an average, this idiosyncratic term that we have is 0, right. So, what I am left with is some average productivity for the firm. Okay. Everyone clear? So, this is just nothing but, so this on an average is 0. So, if I am able to get beta, gamma, delta, then I subtract out from y, or log of y, I will just get omega I, and that is what I am interested in. I am interested in log of a, which is omega I. Okay. But my problem was that I could not observe this, and it was specific to a firm. Now, by just looking at the firm over time, I am able to eliminate this particular idiosyncratic factor. Okay. Now, this method is used for all kinds of estimation in all kinds of work. In household economics, people use panel data, longitudinal data. The whole emphasis is that if households may be different, but as long as they are different in the same way over all the time periods, then it does not really matter, because I can difference it out, right. So, what kind of variation is being used here to get beta, gamma and delta, right. So, let us think about this first. If I ran the Oilless, what variation is being used to estimate beta, gamma and delta? Just simple Oilless. What kind of what variation are you using? You are using variation in, let us say, L. What variation are you using? You are using variation in L across firms over periods of time. So, what are you comparing? You are comparing different firms, right. You are saying one firm has more labor, other firm has less labor, एक period में एक firm का large, firm 1 in period 1, firm 2 in period 3, or everything. You are looking at the difference, and then looking at this variation is giving you something about how output changes. What is being used here? What variation? Exactly. You are asking for this firm, if labor changes, then how does its output change, right? Right. So, the nature of variation, what you have done is you have transformed the data, the nature of variation, to be able to check differences which are in fact valid. So, you have said, well, if I compare your L, your firm's L with his firm's L, but you guys are different because your omega i's are different, right. I will not do that. I will take him and I will follow his firm today and tomorrow, and if his L changes, then that is not because of omega I. I am going to see if his L changes, how does his output change, right. I do that for you, I do that for each person. Okay. I am not beta ka coefficient, beta ka ultimate interpretation is the same. It is the coefficient on the production function. The question is, what kind of variation will yield a true value of beta?
So when I want to interpret beta, is it for one specific firm?
No, it is still this. It is still the production function, right. So, separate, it is not that you are estimating a different beta and giving a different beta for every firm. We do not care. What you are doing is you are using this technique, right. You are ultimately getting a beta. So, what it is doing in some sense, the mechanics of it is that it's basically looking at your changes in L and see how output changes. It's doing that for each person, right, and then it's reporting an average effect across the table, right. But it's not taking your L and saying uska output dekhte hain, iska output dekhte hain. That exercise it's not doing. So the comparison is not across firms, the comparison is within firms. Okay. Okay. Estimation uses only within firm variation over time. So now let's think about the problem of doing so. So this gives you, this eliminates the problem, right, ki omega chala gaya. But as I told you, the world is not so kind. When you eliminate one kind of problem, other kinds of problems come up. Okay. So what did I say was the classic trade-off in all kinds of work? Efficiency and consistency. This is consistent, right, this is not affected by omega I. So there must be some consequence on efficiency. So what consequence does this have on efficiency? Matlab precision of beta, gamma, delta. Remember, what does the precision of beta, gamma and delta depend on? It's the variance of Of which variables? Of the x's, right? The x's here are LIT plus 1 minus LIT, KIT plus 1 minus KIT, MIT plus 1 minus MIT. Exactly. So when you are comparing across firms, इसका लेबर कम है, उसका लेबर बहुत ज़्यादा है, इसका, you get a lot of variance in L, right? So you will get something, it may be completely wrong, but it looks very precise. So you will precisely estimate a wrong number, right? Here you have, by using this trick, eliminated, but by doing, you have created an experiment which has is removed the impact of omega I, but now you are relying on year to year changes in that firm. So you may not change it dramatically every year, each firm may not. So that means LIT plus 1 minus LIT in fact will not change much. In fact, if the firm does the same thing every year, then LIT minus LIT will be 0, YIT plus 1 minus YIT will be 0, so 0 to kuch bhi nahi, you will not be able to learn anything. Okay? So this will show up, this, so fixed effect estimation tends to be lower than between firm variation. This means you are losing a lot of variation in data, right? So usually these make standard errors high, therefore you are likely to see many insignificant coefficients. So you will see standard, whenever you do cross section, sab aa jata result, everything is significant. As soon as you start doing longitudinal data, many things will turn out to be insignificant, right? It does not always mean that that variable is actually not important. It just means that your variation in that variable is so low that it is not able to estimate that parameter precisely, right? So think about it. Let's say I want to look at the impact of caste or religion on a household problem. I have panel data. Can I do it? So let's say I'm looking at schooling choice. I know it depends on many things. I know it depends on caste and religion. ठीक है? तो एक और साल का डेटा तुम्हारा दे दिया मैंने तुम्हारे हाउसहोल्ड पे. Do you think that you can do fixed effects estimation and get the impact of caste and religion? Unless you are changing your caste and religion every year, right? If you don't, then it just gets washed out, it just differentiates out, right? It will remain the same, so you will never be able to estimate. So any variable that doesn't change over time, so you will not be able to estimate that at all, right? So you are relying on the fact that in fact every variable changes to some extent, so that we are able to get some numbers. So the implication of that, talk about the implication of that, is that when people do work, longitudinal work with firms and often with households, people tend to take, so now there is a, it's kind of, econometrics is an art form bolte hain, so it's one of those kind of artsy kind of statements. So even if you have year to year data, many a times you will see people will take data with some distance, especially when people are designing longitudinal surveys, often they don't do it in adjacent years. They will do it like 5 years apart or 3 years apart. Okay? Now it comes with some good things and bad things. Good thing is 2-3 साल में तो कुछ तो change होगा, so you will be able to estimate the parameters. What is the bad thing? Huh? Why did we do it? We wanted to eliminate omega. Omega का assumption क्या था? That omega it equal to omega I, matlab the unobserved thing about you is the same. On a 1 year horizon, that may be a fairly reasonable statement. Maybe even on a 3 year horizon. 5 साल, 10 साल बाद, if you are working on IHDS data, it's a household panel, right? एक 2004 में, एक 2011 में. To assume that the households are exactly the same in unobservables and how, that's like a very far-fetched assumption. It's like 7-8 years apart, right? The households have changed by that time. So sometimes, though you have longitudinal data, it doesn't really buy you much, because it's the fixed effects regression is being run on the assumption that that omega, that unobserved thing, is remaining the same. That's a reasonable assumption in a short period of time. On a long period of time, your referee will send back your paper saying, but it's not, it's too long, the fixed effects is not going to really solve your problem. Okay? So that's the delicate balance. If it's too short, then variation is too low, so you get insignificant coefficients. If that's too long, if you get long periods of intervals, then you get more variation, but you lose this consistency, the fact that you can eliminate omega I from the regression. Okay? So the diktat here is that whenever you do this kind of work and you use annual frequency, just check if you get insignificant coefficients. Just check if you were to take slightly longer, whether you get back some of the significance. Okay, so then you can make this argument to the referee, saying that look, I'm getting a consistent coefficient, but इतना कम variation है year to year में कि मेरा नहीं आ रहा है. But if I do it on 3-year, 4-year lags, I mean this apart, then I'm getting more or less the same coefficient, but now I'm getting significance, so that's fine to do. Okay, so frequency of which you take data is very important. Okay, now that's the second problem. So this is as I said, a classic problem with fixed effects. But as I've said, it's a classic problem with any method that tries to do some, make things comparable. A third problem, which is specific, largely specific to firms, but also specific to households, in fact, is, if you have a panel data, many units, firms, have missing variables, which means that firm hai, and then अचानक firm चला जाता है, right? Household data में तो बहुत ही common है. You go and survey, those 3 साल बाद गए, 20% of the households तो है ही नहीं, right? This is called attrition. Okay, so many of these things, they are missing. So if you're trying to construct a panel, right? This is the plant, period 1, period 2, period 3, and so you're considering 10 years. For many firms, you have data for the first 4 periods, and then you don't see the firm at all in the data. Okay, so the standard practice when you do panel data is that you keep firms who are always in the panel. This is called creating a balanced panel. Okay, why balanced? Because all the firms will have the same number of observations. Okay, but now the question is that you start with the world, okay, and the baseline. Then you move forward trying to trace them over time. Then only half of them after some point remain, the other half doesn't. So now you start asking yourself, अच्छा ठीक है, so let me restrict myself to those who always exist. उनको भूल जाते हैं, right? It will solve which problem? It will still solve the problem that omega I will be differenced out. But now you get the beta L log A for whom? Only these guys, right, who are remaining. But these guys who remain, they are not the same as the people who are not there. Because वो तो निकल ही गए, there must be something different about them, otherwise they would also be still there, right? So what you can get in the end is, if you create a balanced panel, you can often say internally valid things. You can say things about that set of firms that remain. It will not be valid for firms that, the original set of firms that was the population to begin with. Okay, so if ever you work with long-term longitudinal panels, a very important table you need to show is that, like for example households, that those who disappear from your sample are in fact not very different from those who are still in your sample at the end of it. So you take the baseline, then take the end line, then look at the households that remain in the end line and those who don't remain in the end line, right? And then check the initial characteristics of these firms or households, right? It better be the case that they are not too different. If the ones which have disappeared look very different, then you are not making a statement about the world. You are making a statement about only those firms who still remain or those households who remain. Okay? So this table is very important whenever you do panel data work, is to show that you still have some, you're making a more general statement than just the statement of the persons who remain, right? At the extreme, think about firms. If only the most efficient firm remains after 10 years, then doing a fixed effect on him not relevant to understand the industry, because this is the only firm that remains and it's the only firm which, it must be very different, right? And how can you learn anything from that firm and then generalize to the industry, right? So that problem will remain when you have larger number of firms. Okay. Now what if, so the important thing is, what if the exit decisions of firms that are in the sample biases the estimates, right? So one is to say, let's create the balanced panel, the other, and let's be internally consistent, but you can get situations where everything that you do may be wrong. Okay, and I'll talk more about it later. So there are some standard ways in industrial organization and in trade to firm productivity to address these problems. Okay, and most of them are now, anything that's a canned program in Stata, it means that it's not very difficult to do. So one should know what it means and how to do it. Okay, so I'm not going to tell you how to do it because it's just one command. Okay, you can just start, you can just look for one of these things, Stata in Google, and just give you the, you know, it will give you the command, and you can just run the command in Stata, or, you know, I think even R has it. So I'm going to talk about two papers. Actually, I'm going to talk about the procedures in these two papers, called Oilless and Levinson-Petrin, which is a way to deal with problems when you're trying to get estimation of productivities from firms, when firms are kind of, you know, have those biases we have talked about, and they have also this problem that you have this attrition happening in the sample where firms are exiting. Okay. Okay. So the classic way to solve many problems in development economics is to run experiments, right, like RCT and stuff. When it comes to, as I said, firms, macro, you cannot do those things. So you have to then use a bit of theory and econometrics to be able to find some ways out of these problems. You cannot ignore the problems, but you have to find some ways out which are not based on an experiment. So what we are going to do in this model, it's a very simple model. I mean, you know, let me not say that. So I think when I was a student and teachers would say simple model, and then kuch samajh nahi aaya. So it's a model. It doesn't make any assumptions that you know more than what I tell you. Okay. It's a dynamic model of firm behavior, which means that we are going to look at over time, and that's important because we have just talked about issues which are over time. So we have to think about how firms behave over time. It's going to be a model that tackles simultaneity of input choice, which means that L, K, M, all these things are being chosen at the same time. So that's one problem we know exists, that based on, you know, productivity and intermediate inputs, firms are making choices of workers, how much capital, and so on and so forth. And but it makes explicit what is known at the time that inputs are made. When do you choose labor? When do you choose capital? Right? It's going to make assumptions on this, but these are assumptions that can be checked in the data, and in fact they can be checked with industry, you know, people who work in industry and stuff like that, right? So for example, capital, you know, you don't make new capital investment every day. You don't suddenly, you know, throw out your machines, right? Just ki hamara mera K kam hona hai, I want to reduce my K, I don't just shut down and throw out my machines, right? So some decisions are made before other decisions, and so it will use some of the timing of that, and it will tackle the third problem, which is it will deal with firms that are exiting the sample. So this model must be able to generate some sort of an exit rule that we can use to tackle in the data. Okay. So remember, these are the classic problems I've talked about: simultaneity of input choice, the dynamic thing because we want to take care of this omega, and we need to basically deal with firms that exit the sample. Okay. So first, what does it say about the timing? Okay. So it says that at the time a firm makes a decision, what is known to it? So it of course has information about itself, right? So it knows what its capital stock is. It knows ki kitne machine mere paas hai. Okay. It knows, it has an index of firm's efficiency, so it's omega. So it knows, you know, whether it's good or bad, right? But this paper will in fact assume that it's the positive thing about this paper, that this omega is it's not the same number every year. It's not that it's fixed every year. So this omega is a random variable. It's like a productivity shock, which is revealed to the firm at the start of every period. So like omega is revealed to it every period. But that would be really odd if, you know, I'm a smart firm, omega mera leave ho raha hai, then I don't forget. Next period again omega ho raha hai, you know, it's a modeling thing for me. But to assume that the firm will forget its omega next period is crazy. So the way to model that recall is that these omegas are correlated over time, which means that firms with higher omega today are more likely to have a higher expected omega in the future. So if I'm a smart firm, I know tomorrow also I'm smart, after that also I'm productive. So you may pata hai. It's not a fixed number, it's still, there's some stochastic nature to it, but it's a highly persistent stochastic variable. Okay, now I have to make decisions about how many people to hire, what to do, so I must know something about input prices, right? But if I am solving a dynamic problem, so I'm deciding what to do today, what to do tomorrow, and so on and so forth, I must know what the input prices are today and have some idea about what the input prices will be in the future, right? So I must have some notion, some probability over future input prices, right? So some idea of what will happen in the future. And we'll assume that same across all the firms, that more or less all of them kind of know in the same way what's going to happen in the future. Okay. Now, none of these assumptions are necessarily true, okay, but it's important to start with this baseline. If you want to change anything, you have to understand why you, in the simple structure, what do you get, and then if you change something, then it's a deviation from that. So what's the decision timing? At the beginning of a period, a firm makes 3 decisions. Decides to exit or continue in operation, right? So whether I'll just scrap value, I'll just sell my firm. If it exits, it receives the selling value of the firm, let's call it phi, and never appears again. So bech diya business, khatam. Okay, can't do it. If it continues in operation, then it chooses investment, and then it chooses labor, how many people to hire. Okay. Okay. So this is basically this is the structure. That's simple. और कुछ नहीं है. Just the only thing is it's making the timing and how you're modeling these omegas explicit. ठीक है. So this is a stylized version of the world. Okay. If any of those assumptions are not true, then you will get some other results which you can work out, but at least you know where to start. Okay. So let's say that we do simple Oilless. Okay. So we take all the firms and run this regression given this model. Okay. So now one good way to think about how to solve problems is to ask yourself, are there reasons why you would expect particular kind of biases? Okay. In principle, biases which are against your result, they are kind of fine. So you say that this thing has a 10% effect. It could be even more because there is some epsilon which moves the other way. So it's a 10% effect. In principle, it could be even more than 10%. I think you'll be able to sell your paper. People will say, "अच्छा ठीक है, you've shown at least 10% है, और ज़्यादा भी हो सकता है," right? So those kind of biases are great for you. You feel like you're almost doing people a favor. मैं 10% दिखा रहा हूँ, पर actually effect और भी ज़्यादा है, right? The problem is when you get a 10%, but the correlation in the epsilon is such that it's actually much lower, right? Then you are overclaiming. Overclaiming is bad. Okay, underclaiming is fine. Okay, so one of the problems in running these biases is to understand what is the nature of these biases. So you expect more productive firms to hire more labor. Right? I mean, they know they are going to expand, they are going to do more. They are a smart firm. So you expect this correlation to be positive. So this is an upward bias. So what you get on beta k, if you run an Oilless, will be actually much larger because it will also not accounting for omega, right? Just run a regression where omega is in the error term. You are going to get a coefficient on L, which is going to be larger because firms which have higher labor are also smarter firms. Okay, that's a typical kind of bias we think about. But there will be another bias which is not so obvious unless you think a little more. This is basically introduced by the self-selection of these firms, okay, by shutdown. So now think about, to understand shutdown, like exit from industry, think about who survives in the industry, right? So survival will depend in part on TFP, revealed every period, मतलब कितना productive हो, right? So higher the omega, the more productive you are, the better chance that you will survive. Okay. So what is the problem that when you get? So when do firms exit? So suddenly price come ho gaya. Suddenly what you are seeing in the industry, that particular year US shuts down, embargo kar diya, right? You get a big shock to your firm. I am producing some product, this year for some reason I cannot sell. It will be sorted out over time with Trump, but now it will take a year or two. Okay. So firms which get a bad productivity shock in any period can withstand it if they have a large capital stock. So there are some firms who suddenly they hear in 1 year that things are not good, they will not shut down because they know it will be resolved. I'm a big firm, I can take these shocks, I'll survive, I'll see what happens next year, right? Now those firms which are really, really small, right, they'll be the first ones to say, yaar, ye to mera rozi roti hai, nahi mila, band ho gaya, shut down. Okay? So that means that the firms that will in fact survive will basically have, will be much more productive, right? But there is a correlation here. So when we are looking at the effect of capital on output, we will underestimate it because, so let's say that you observe, so today you observe some low capital firms and some high capital firms, right? So what must be true? It must be that shocks that have hit, so this small hai, matlab they must have had small shocks. नहीं तो बड़ा शॉक होता तो निकल ही जाते, right? Whereas big firms, इनका शॉक अच्छा भी हो सकता है पर खराब भी हो सकता है because they can withstand bad shocks, right? So what will tend to happen is the firms which are small in size at any given point in time will tend to be also firms which have been lucky, right? They have more or less had positive shocks, right? And the firms which are bigger, because they can take more bad things, on the average they may be lucky or unlucky, but they can take it, right? So the smaller firms are in fact the luckier firms, the more productive firms, right? So that means that if you compare K, if you compare two firms which are low K and high K, the high K firm will on an average have lower productivity shock than smaller capital firms, which must have been these lucky firms because these are the existing firms. So they must be the lucky firms. Okay? So to think about this, just think that there are two shocks, high and low, right? And so there are some big firms and some small firms. You follow them over some period. The big firms will basically be able to take both high shocks as well as low shocks and they'll survive. But tomorrow I only observe the small firms which have been lucky to get just the low shock, right? All the high shock wale sab immediately exit kar gaye, right? So then where on an average when I look at shocks, which will tend to have more, I mean low shock here is good. Which of the firms will tend to have more, and as a proportion, a higher number of low shocks? It's the smaller firms because they are the ones who are existing, so they are lucky ones, right? So you don't need luck so much when you are a big firm. So that means that, so remember what are we worried about? So high K is then associated with on an average lower omega, right? Because omega is a positive shock. मतलब omega तो कम भी हो सकता है उनका. Whereas low capital firms, they are the lucky firms. So they must have had high omega. मतलब they have had good productivity shocks, right? So now that means that K ऐसे ऊपर होता है, omega at the same time नीचे होता है, right? And now so basically what you will get, you will tend to underestimate because they are not moving positively together, they are moving in the opposite direction. So the coefficient on K will tend to be lower than it truly is if I held omega constant. Yeah. Said firms, macro, you cannot do those things. So you have to then use a bit of theory and econometrics to be able to find some ways out of these problems. You cannot ignore the problems, but you have to find some ways out which are not based on an experiment. So what we are going to do in this model, it's a very simple model. I mean, let me not say that. So I think when I was a student and teachers would say simple model and then kuch samajh nahi aaya. So it's a model. It doesn't make any assumptions that you know more than what I tell you. Okay. It's a dynamic model of firm behavior, which means that we are going to look at over time, and that's important because we have just talked about issues which are over time. So we have to think about how firms behave over time. It's going to be a model that tackles simultaneity of input choice, which means that L, K, M, all these things are being chosen at the same time. So that's one problem we know exists, that based on productivity and intermediate inputs, firms are making choices of workers, how much capital, and so on and so forth. And but it makes explicit what is known at the time that inputs are made. When do you choose labor? When do you choose capital? Right? It's going to make assumptions on this, but these are assumptions that can be checked in the data, and in fact they can be checked with industry, people who work in industry and stuff like that, right? So for example, capital you don't make new capital investment every day. You don't suddenly throw out your machines, right? Just कि हमारा मेरा K कम होना है, I want to reduce my K, I don't just shut down and throw out my machines, right? So some decisions are made before other decisions, and so it will use some of the timing of that, and it will tackle the third problem, which is it will deal with firms that are exiting the sample. So this model must be able to generate some sort of an exit rule that we can use to tackle in the data. Okay. So, remember these are the classic problems I have talked about, simultaneity of input choice, the dynamic thing because we want to take care of this omega, and we need to basically deal with firms that exit the sample. Okay. So, first what does it say about the timing? Okay. So, it says that at the time a firm makes a decision, what is known to it. So, it of course has information about itself, right. So, it knows what its capital stock is, it knows ki kitne machine mere paas hai. Okay. It knows it has an index of firm's efficiency, so it's omega, so it knows whether it's good or bad, right. But this paper will in fact assume that it's the positive thing about this paper, that this omega is it's not the same number every year, it's not that it's fixed every year. So, this omega is a random variable, it's like a productivity shock which is revealed to the firm at the start of every period. So, like omega is revealed to it every period, but that would be really odd if I'm a smart firm, omega mera leave ho raha hai, then I don't forget next period again omega ho raha hai, it's a modeling thing for me, but to assume that the firm will forget its omega next period is crazy. So, the way to model that recall is that these omegas are correlated over time, which means that firms with higher omega today are more likely to have a higher expected omega in the future. So, if I am a smart firm, I know tomorrow also I am smart, after that also I am productive, so you may pata hai. It's not a fixed number, it's still there is some stochastic nature to it, but it's a highly persistent stochastic variable. Okay. Now, I have to make decisions about how many people to hire, what to do, so I must know something about input prices, right. But if I am solving a dynamic problem, so I am deciding what to do today, what to do tomorrow and so on and so forth, I must know what the input prices are today and have some idea about what the input prices will be in the future, right. So, I must have some notion, some probability over future input prices, right. So, some idea of what will happen in the future, and we will assume that same across all the firms, that more or less all of them kind of know in the same way what is going to happen in the future. Okay. Now, none of these assumptions are necessarily true, okay, but it is important to start with this baseline. If you want to change anything, you have to understand why in the simple structure what do you get, and then if you change something, then it's a deviation from that. So, what's the decision timing? At the beginning of a period, a firm makes 3 decisions: decides to exit or continue in operation, right. So, whether I'll just scrap value, I'll just sell my firm. If it exists, it receives the selling value of the firm, let's call it phi, and never appears again. So, bech diya business, khatam, okay, can't do it. If it continues in operation, then it chooses investment, and then it chooses labor, how many people to hire. Okay. Okay. So, this is basically this is the structure, that's simple, aur kuch nahi hai, just the only thing is it's making the timing and how you are modeling these omegas explicit. Okay. So, this is a stylized version of the world. Okay. If any of those assumptions are not true, then you will get some other results which you can work out, but at least you know where to start. Okay. So, let us say that we do simple Oilless. Okay. So, we take all the firms and run this regression given this model. Okay. So, now one good way to think about how to solve problems is to ask yourself, are there reasons why you would expect particular kind of biases. Okay. In principle, biases which are against your result, they are kind of fine. So, you say that this thing has a 10% effect, it could be even more because there is some epsilon which moves the other way. So, it is a 10% effect, in principle it could be even more than 10%. I think you will be able to sell your paper, people will say, theek hai, you have shown at least 10% hai aur zyada bhi ho sakta hai, right. So, those kind of biases are great for you, you feel like you are almost doing people a favor, main 10% dikha raha hu, but actually effect aur bhi zyada hai, right. The problem is when you get a 10%, but the correlation in the epsilon is such that it's actually much lower, right, then you are overclaiming. Overclaiming is bad, okay, underclaiming is fine. Okay. So, one of the problems in running these biases is to understand what is the nature of these biases. So, you expect more productive firms to hire more labor, right. I mean, they know they are going to expand, they are going to do more, they are smart firm. So, you expect this correlation to be positive. So, this is an upward bias. So, what you get on beta k if you run an Oilless will be actually much larger, because it will also not accounting for omega, right. Just run a regression where omega is in the error term, you are going to get a coefficient on L which is going to be larger, because firms which have higher labor are also smarter firms. Okay, that is a typical kind of bias we think about. But there will be another bias which is not so obvious unless you think a little more. This is basically introduced by the self selection of these firms, okay, by shutdown. So, now think about, to understand shutdown, like exit from industry, think about who survives in the industry, right. So, survival will depend in part on TFP revealed every period, मतलब कितना productive हो, right. So, higher the omega, the more productive you are, the better chance that you will survive. Okay. So, what is the problem that when you get? So, when do firms exit? So, suddenly price come ho gaya. Suddenly what you are seeing in the industry, that particular year US shuts down, embargo kar diya, right. You get a big shock to your firm. I am producing some product, this year for some reason I cannot sell. It will be sorted out over time with Trump, but now it will take a year or two. Okay. So, firms which get a bad productivity shock in any period can withstand it if they have a large capital stock. So, there are some firms who suddenly they hear in 1 year that things are not good, they will not shut down, because they know it will be resolved. I am a big firm, I can take these shocks, I will survive, I will see what happens next year, right. Now, those firms which are really small, right, they will be the first ones to say, yaar, ye to mera rozi roti hai, nahi mila, band ho gaya, shut down. Okay. So, that means that the firms that will in fact survive will basically have, will be much more productive, right. But there is a correlation here. So, when we are looking at the effect of capital on output, we will underestimate it, because, so let us say that you observe, so today you observe some low capital firms and some high capital firms, right. So, what must be true? It must be that shocks that have hit, so this small hai, matlab they must have had small shocks, nahi to bada shock hota to nikal hi jate, right. Whereas big firms, इनका शॉक अच्छा भी हो सकता है पर खराब भी हो सकता है, because they can withstand bad shocks, right. So, what will tend to happen is the firms which are small in size at any given point in time will tend to be also firms which have been lucky, right. They have more or less had positive shocks, right. And the firms which are bigger, because they can take more bad things, on the average they may be lucky or unlucky, but they can take it, right. So, the smaller firms are in fact the luckier firms, the more productive firms, right. So, that means that if you compare K, if you compare two firms which are low K and high K, the high K firm will on an average have lower productivity shock than smaller capital firms, which must have been these lucky firms, because these are the existing firms. So, they must be the lucky firms. Okay. So, to think about this, just think that there are two shocks, high and low, right. And so, there are some big firms and some small firms, you follow them over some period. The big firms will basically be able to take both high shocks as well as low shocks, and they will survive. But tomorrow, I only observe the small firms which have been lucky to get just the low shock, right. All the high shock wale sab immediately exit kar gaye, right. So, then where on an average when I look at shocks, which will tend to have more, I mean low shock here is good, which of the firms will tend to have more, and as a proportion, a higher number of low shocks? It is the smaller firms, because they are the ones who are existing, so they are lucky ones, right. So, you do not need luck so much when you are a big firm. So, that means that, so remember what are we worried about? So, high K is then associated with on an average lower omega, right, because omega is a positive shock, मतलब omega तो कम भी हो सकता है उनका, whereas low capital firms, they are the lucky firms, so they must have had high omega, मतलब they have had good productivity shocks, right. So, now that means that K ऐसे ऊपर होता है, omega at the same time नीचे होता है, right. And now, so basically what you will get, you will tend to underestimate, because they are not moving positively together, they are moving in the opposite direction. So, the coefficient on K will tend to be lower than it truly is if I held omega constant. Yeah. Higher K firms will tend to be a firm where they have got a distribution of, in some sense, all high and low omega, does not matter, right? But the existing small firms must be firms which have got higher omega, right? So then, higher K means on an average lower omega, and so the bias goes the other way, okay? So it means that ये भी number गलत है, पर ये नीचे की तरफ है, तो L ऊपर की तरफ है, ये नीचे की तरफ है, right? So we have to figure out some way to solve this problem. Okay. So now the thing is, the trick is to be able to take care of omega IT. Okay, and remember, if I do fixed effects, if I have long data like prowess, go for 15-20 years, assuming that omega I is the same for the firm, that we have given up. We have said that maybe that's not a good idea. Okay, we have said that. So what have we bought instead? We have said that firm जो smart है, वो on an average future में smart रहता है, but guaranteed नहीं है. Right? Could be that it also has a bad shock. So we are going to try to take care of the unknown omega, but we'll do it in a structural way, right? Something that kind of is honest to the structure of what we have taken into account. So we are going to use the fact that if you look at investments, then remember you make investments when, so you're a firm, you observe your productivity shock, you have a capital stock, you decide should I buy more machines or not, okay? मेरा फैक्ट्री है, ऑर्डर अच्छा मिला है, I already have certain number of machines, should I buy, invest in some more machines? Okay, that's investment. Okay, so investment is a function of that. Now, if investment is positive, you can show under this structure that we have taken that this function is invertible. Matlab, if I is a function of omega and k, then omega is some function of I and k. Okay, now what function it is we don't know explicitly, but it's some function of I and k. Invertible matlab, in principle, it's something that you can do, right? But you cannot really know exactly what h is, right? So omega is some function of I and k. What's the advantage of this? Of course, I still don't know what omega is because मुझे h पता नहीं क्या function है, right? I know in principle it's invertible, मतलब एक कोई function है जो कि invert कर सकता है इसको, right? But I have data for I and I have data for k. Okay, so I express omega in terms of I and k. But I don't know the value of omega because of course I don't know what this function is. Okay, but let's take that understanding forward and go. So let's say y is now, now I put a beta naught just to make life simpler. By the way, what does beta naught do if you have a coefficient, if you have an intercept term in a regression? So I was running everything without beta naught. Now I put a beta naught. You know? हाँ, एक ये है और एक ये है. One is y equal to beta x plus epsilon, the other one is y equal to alpha plus beta x plus epsilon. What's the difference between the two? वो तो x0 है तो y0 है. Actually it's not y, it's the expected value of y because epsilon will. What is the difference between the two? Which is more restrictive? The first one is more restrictive, no? Because obviously alpha equal to 0 hai wo. But what does this alpha buy you?
The dependent variable depends upon the initial condition as well as the independent.
It's got to do with some assumption she talked about. The expected value of u equal to 0.
Suppose we try the consumption function. The consumption function is some consumption function, then initial value, then the monetary value. This means the consumption cannot be 0.
Yeah, it means all those things, but it makes life very simple for an assumption that she made. She said expected value of epsilon, or you said u, but it's the same, epsilon. The expected value of epsilon is 0. That's one assumption you need. That's an assumption, right? But that is actually a more reasonable assumption here than there. Why? Ask yourself, what if this is not true? What if expected value of epsilon is equal to mu? Right? After all, epsilon is, I don't know what epsilon is. उसका average, मैं बोला वो 0 है, तो नहीं जीरो नहीं है यार, वो म्यू है, right? In this model you can't allow that, right? Here you can show that even if the expected value of epsilon was not 0, then that mu will be picked up here in alpha, right? You can show that essentially the intercept term takes care of any assumption that you make on the error term. So if the error term expected value of epsilon was not 0 but was mu, then the coefficient you would get is basically the mean of the error term. Okay? So the intercept term helps remove this very restrictive assumption that on average the error term must be 0. Okay? So in this model, epsilon equal to 0 is a fairly reasonable assumption, because at least alpha will take care of if it's not 0, right? So that if this was if this is the true model and the expected value of epsilon was mu, then what you will estimate in the Oilless regression is alpha plus mu, right? So the intercept term will be little off, but beta will be fine and all these things will be fine, so you're fine. So it helps in some way release the pressure from this assumption, the expected value. ये बहुत बड़ा assumption नहीं है फिर. It's like it's fine. गलत भी होगा तो alpha will take care of it. Okay, so typically people run, so like Stata typically will give, this is the default option, unless you don't want a constant intercept term, you will always get an intercept term because it's just got better, it's got more flexibility. Okay, so let's go back to the problem. So remember this y was beta naught or beta plus kit plus lit plus omega it, right? So now instead of omega it, I write htit kit, right? But of course I cannot write the value because I don't know what h is. In principle I can write that hit. Okay? So now what we can do is, let's say that we know it's a function of I and k. Let's take a very, very less restrictive, like very super kind of polynomial approximation, fifth order polynomial approximation, right? कि जो भी function है उसका मैं एकदम get some approximation to that, right? People do 6th, 7th, I mean as flexible as you can, okay, an approximation. But now notice that if it's an approximation, then one problem is that इसका कोई linear term होगा, like this h of I kt will be some some a times I plus b times k plus I times into k plus I square plus k square plus I cube plus k cube I k square, मतलब जितना तुम कर सकते हो, पर उसमें एक term है a plus a it plus b times k it, ठीक है? तो मतलब यहाँ पे एक b k it है और यहाँ पे भी एक बीटा k है, right? So when you run the regression, what will you estimate as the coefficient of kit? Beta k plus जो approximation में coefficient है. So it doesn't solve the problem. Okay? So this is a problem that will come across. So the way out is to basically do it this way. So अगर हम estimate नहीं कर सकते हैं, so let's say that we figure out कि let's say this is our function, beta naught plus beta k times kit plus ht it kt, इसका this is some function, let's call it phi of I and k, ठीक है? So remember we cannot separate out beta k and the something there, so we take the whole thing and say let me call it some function phi I kt. It's a function of I and kt, उसमें I linear term है, quadratic है, cubic है, जो भी है, ठीक है? And let me put it here. Okay, so y becomes now beta l times l plus phi it plus epsilon it, ठीक है? ये रहा, ये बाकी पूरा part I have approximated with some function, third, fourth order polynomial. Okay, the polynomial is in terms of I and k. Yeah, and the beta naught. So it will have its own coefficient because it's a polynomial version, right? Okay, but now I have in some sense explicitly by approximation taken care of omega k everything here through the phi, right? So what I get as the coefficient of L, ये तो ठीक है, there is no problem, right? So that's beta L. So that means I can run a regression of y on L and this polynomial approximation in terms of I and k, and what I will estimate will be coefficients of phi, which I cannot separate out into beta k and all that. but I will get some approximation here. But I am not interested in that to begin with. I am interested in beta L. तो मिल गया इससे beta L. Okay. Remember, there is no L in this approximation. Okay. So now for the moment, assume that there is no attrition. So this is step 1, right? In step 1, we just take an approximation of I and k, and we have data on L. We put that in, and what we get as the coefficient of L is the true beta L in terms of what I want to estimate. Now suppose there is no attrition, that means firms don't disappear. Then now I have done the first estimation. I have output data, I have estimated beta L, L का data तो है ही. So for each firm I calculate y minus beta L times L, right, as the second step, because I have estimated beta L. I know each firm का L क्या है और y क्या है. Let's call that V. Okay. And then I know that if my form is true, then this V is equal to beta k times k plus omega t plus epsilon I t. Right? ये omega मैंने पहले वो लिखा था phi y करके, right? तो ये तो the basic regression is this. Okay. So now I have one part. Now I want to get this beta k, because without this beta k I can't do anything. So now move to the second assumption. Since omega t follows a time series process, that means omega I said are random variables that are correlated over time, right, for each firm. So in particular, omega t is a function of omega t minus 1. This is called a first order Markov, nothing but an AR1 kind of model, where your previous period productivity has a high correlation with this period's productivity, right, except that in AR1 it's like alpha times yt minus 1. Here you are being extremely generous. You are not saying ki alpha, you say just some function g of omega t minus 1. Okay. So what can we do? Well, now notice that omega is a function of omega t minus 1. So omega t minus 1 क्या है? It's ht minus 1, it minus 1, kt minus 1, right? So omega t is omega t minus 1 के जगह ये ht minus 1 लिख दो, ये हो गया, right? Now, but this is what ht minus 1, but this is just g of, so what is ht minus 1? Let's go back. ये phi है, so phi t minus 1 is equal to beta naught plus beta k kit plus ht. So this is equal to phi minus beta naught minus beta k kit is equal to ht minus 1. Okay, everyone, let me write it down so that it's clear. You say just some function g of omega t minus 1. Okay. So what can we do? Well, now notice that omega is a function of omega t minus 1. So omega t minus 1 क्या है? It's ht minus 1, it minus 1, kt minus 1, right? So omega t is omega t minus 1 के जगह ये ht minus 1 लिख दो, ये हो गया, right? Now, but this is what ht minus 1, but this is just g of, so what is ht minus 1? Let's go back. ये phi है, so phi t minus 1 is equal to beta naught plus beta k kit plus ht. So this is equal to phi minus beta naught minus beta k kit is equal to ht minus 1. Okay, everyone, let me write it down so that it's clear. Which is a function of omega t minus 1. ये assumption है. It's a first order Markov. You can do it with second order also, but just first order भी करो. Okay. So this omega t minus 1 we know is ht minus 1, it minus 1, kt minus 1. So मतलब previous period का omega है, तो वो it's invertible with respect to the investment in the previous period and the capital stock, right? Now we also know that earlier we have basically found, we have defined phi t as beta naught plus beta k kit plus ht it kt, ठीक है, but we want ht minus 1, ठीक है. So let's ये minus 1, ये minus 1, ये minus 1, ये minus 1, ये minus 1. Okay, that means that ht minus 1 equal to phi t minus 1 minus beta naught minus beta k kit minus 1, ठीक है. Okay, so how does that help us? Because I know now that ht minus 1 is this, so इस वाले में this is g of phi t minus 1 beta naught kit minus 1, ठीक है. Now main problem is we don't know g, right? So we approximate g again with another polynomial. But इस polynomial में क्या क्या terms हैं? It's a function of phi t minus 1, which I know because once I estimate this, I know what the value of phi is, right? Beta इसका जो भी firm specific ये आएगा term, this will be phi t. So I know these phi t's. So I know beta L and I know phi t from this estimation. So it's basically the firm specific kind of terms. So basically what I'll do is this is data, I write down a approximation in terms of phi t minus 1 and ki t minus 1. Okay? But how does this solve the problem? What's the difference between this and this? यहाँ problem था that this h term here, yeah. So this is the term, right? So whatever be yit, whatever be lit, the residual of that under assumption that this is expected value is 0, this is going to give you values of phi it for each firm, because there is yi, right, and there is li for each firm. Yeah, of course. Sorry, L is known, right? You are basically running a regression on y L, okay, and this remember is there are terms in it. There are I and k, so it's some function of, you know, it will be like some a times I plus b times k plus c times I square k. When you estimate this by Oilless, you are going to get coefficients in front of all these terms, right? So now if I have a firm and you tell me what the I and k is, I can tell you what the phi is, right? It's an approximation. It has no connection with beta k, but still all the terms of the approximation are there, right? So think about, for example, a second order approximation. So let's say that, you know, it is, you know, a plus b it plus ci kit plus d it times kt. That's a simple one. Let's say that's the approximation, right? So now let's substitute that. So you get yit equal to beta L lit plus a plus b it plus c kit plus d it times kt plus the error term. I run the Oilless estimation, I get beta L hat, I get a hat, b hat, c hat, d hat. ठीक है, ये term क्या है? This is phi, right? So in this step, put values of it minus 1, kt minus 1, फिर it minus 1, kt minus 1, and for each firm I can tell you what the phi it minus 1 is. So that's data, right? So ये data है, kit भी data है. So I can write down another approximation in terms of phi it and kit. Okay? But the important part is that if you see this beta k has kit, the approximation is in terms of kit minus 1 and phi it minus 1. What was our problem here? That this approximation was in terms of it and kt. So you know this part of, you know, this part c kit was getting, you know, added to the beta k, and so what you were estimating as the coefficient of kit was beta k. So you know what were we doing? So here, if I ran this without, let's look at it again. Okay, of it kt is some, you know, let's forget the, so it's like some delta naught times it plus delta 1 times kt plus delta naught times delta it times kt. So that was the function h. Okay, that's the approximation. So if I put this approximation in that regression, you will see it's yit equal to beta naught plus beta k kit plus beta L lit plus अब ये approximation delta naught times it plus delta 1 times kit plus delta 3 times or delta 2 times it times kit. Okay, what was the basic problem in running this regression? ये beta k, तो regression तो run होगा it kt और it times kt पे ना. So what you will get as the coefficient of KIT will be beta k plus delta 1. But that's not what you want. You want beta k, right? But now, because of this trick, what you get here is these terms are all in terms of the lags, right? So whatever you get here is going to be beta k in front of KIT. Okay? So what was crucial here to do? The crucial assumption here, which you should think about, and this is a trick, is that you were able to write these omegas as a function of previous year's omegas, right? So there is a stochastic assumption about omegas, how productivity moves. So as long as you say that omega has some information, omega t minus 1 has some information about omega t, immediately you can invert, you can represent omega t in terms of omega t minus 1. Omega t minus 1 is a function of it minus 1 and kt minus 1. कोई functional form है जो नहीं पता है, we just put a polynomial approximation. But now in this regression, the coefficient of beta k is estimated separately from the rest because everything else is in terms of the lag, right? It looks like a trick, it is, right? But notice that what is the big advantage? So far we are not dropping any firm, doing nothing, right? We are taking care of omega. If you believe that this stochastic process is different, you write omega t in terms of omega t minus 1, omega t minus 2, all these, anything you want, right? But you know, it's explicit. Okay, this was the model without attrition, matlab firms remain. What is the difference when the firms don't remain? So with attrition, what you can do is you can estimate a probit model of survival. So what do? You take all the data and you find the probability that the firm is still present in that period, right? It's a function of all the covariates. So all of you know a logit model, probit model? Everyone here? It's just a model which the y is the probability that 1 or 0, okay? So just like you can ask in every period, ये firm है कि नहीं है, right? It's a function of a lot of variables, and once you estimate that, you can basically say what is the probability of survival of this firm in every period, okay? So once you do that, that's data. Once you run the probit model, that's data for you. So you know, I'm not complicating things, the paper is very complicated, but essentially what you can show, the only difference it makes is in this g function, instead of just being a function of phi t minus 1 and kt minus 1, it's now a function of phi t minus 1, kt minus 1, and the probability of survival till the last period, okay? Only these three things, right? And once you do that, you are basically correcting for attrition, okay? So how many of here know Heckman correction? Anyone knows Heckman correction? I have gone way over time. Okay, 5 more minutes. We'll finish. Then the trade thing. So, you know, one problem that we have whenever we work with data which is selected, which means that you're not observing the whole population, but you're observing some part of the population, okay, is to basically model who you're seeing in the data, okay. So like labor force, there are only some people who do salaried jobs for whom we have wages, and then others we don't have their salaries because they're farmers. In the NSS, for example, they're farmers, businessmen, right? So when you're running a regression on wages and schooling, you're only able to, you only have that data on people who are salaried, okay. So Heckman basically showed that if you use only that selected part of the data, then you get a bias. The bias is basically because there is a probability of being in the sample which you're ignoring, biasing your results, okay. And he shows that if you account for it by explicitly a term which takes the probability of being in the sample as another covariate, it's called the inverse Mills ratio. If you take into account that, then it solves the bias, okay. This particular correction is exactly in the same spirit, that you're essentially taking into account the fact that, you know, there's a probability of selection, and probability of selection is another variable in your approximation here, okay. So in terms of when you do it, you will realize how simple it is, because इसमें क्या है, polynomial approximation कोई भी लिख सकता है, you know, a plus b square plus c square, right? You get data, You have all the data. There's nothing that is explicit. You know, phi t is again some polynomial approximation. So again, some function of kit minus 1, it minus 1. So it's like it will take you like 5 minutes to do, right? You have investment data, you have capital stock data, you have labor data, you have YT. All you have to do is run 2 regressions, one a probit model and one a model in terms of approximations of these variables. So first regression is this one, second regression is this one, and the third regression is the probit model, right? And karke you just, once you do it, lo and behold, you have coefficients for beta L, beta K, you have the residual, everything is being estimated consistently. So in terms of, you know, it's so standard that now there is a package for it, which so that you don't even have to run the 3. You just have to state and it will automatically do it for you, okay? But it's very important to do, because in fact if you write a paper on productivity and don't do, this is called an OP procedure, your paper will be thrown out by saying you have not taken care of selectivity bias and all the simultaneity bias. It's almost like the most important thing you have to do if you do TFP, okay? People will not accept your results without it, okay? The only difference, last slide for this session, is one problem with the OP is it requires inversion, but this that means IT is a function of omega t kt, so the omega t is a function of IT and kt. This is only true when investments are positive, right? So you see firms investing. But the problem is, in real life, huge number of firms report zero investment, because हर period में तो कोई firm invest नहीं करता है, right? So the same idea in the second paper by Levinson Petrin uses the same idea, except that omega is now a function of MT and KT. MT is the materials, investments in, not investments like expenditures in electricity, water if you are using water intensive products, all intermediate inputs, and KT, right? Now this induces some endogeneity problems, but you can use the same logic, and this LP, Levinson Petrin paper, basically works out the algorithm with exactly the same idea that omega will now be inverted in terms of MT and KT with some, you know, corrections for endogeneity, and it will give you exactly the same thing. Again, Levinson Petrin is a standard package thing where you can just run a Levinson Petrin and you will get your answer, okay? So Oilless gave the basic idea that ऐसे कर सकते हो invert करके. Levinson Petrin said, okay, but you are asking for us to give investment data, but you know this condition does not hold for firms. So let's do it in terms of things that we see firms spend every year, like materials, right? And we can do the same inversion, need a little more finessing on endogeneity, but having done that, you're going to get your answer, which will be consistent, will take care of these productivity differences across firms, and which will take care of selective attrition across firms. Implementing is just a breeze, okay? So why do I do this with you guys? I do it with you guys because, first, if you did not like anything in this particular presentation in terms of assumptions, then it's something that you should think whether it's relevant for your work. Because the thing I always fear, whenever something is very easy to do, people do it without thinking, okay? So whenever you do this, your referee is going to ask questions like, yeah, but you know, is this really worth doing? Was this worth doing? Like for example, in India, if you use prowess data, no, exit is never a problem. It's anyway the data set on very big firms. Firms don't exit so much, right? In more bigger data sets where there are like small firms, you'd see exit more. But in bigger data sets, you know, big firms will hardly exit. So in the prowess, firms will kind of keep disappearing, but then they enter. मतलब एक साल दो साल भूल गए थे या return file नहीं किया या did not give prowess the data, but they have not disappeared. They are just for those periods did not report the earnings, right? That's different from firms shutting down and leaving the industry, right? So then should you be controlling for PT minus 1, because it will increase the procedure, it will take time, right? So you can make smalls if you believe that firm productivity does not depend on one period lag, but a different period lag, because that's what determines productivity. Then you change that assumption and see what implication of the model. Not so difficult to do, right? So people when they see these procedures often ask you these kind of questions, right? But if you pretended that this literature did not exist and worked on productivity in India, you know, people are just going to throw your paper out, saying कि ये तो LP और OP नहीं करोगे तो, you know, at least show us the results, okay? And again, they're very easy to do. So that's important. You should know the theory.